Wow, what a night, guys. Hey, welcome. It's tax day. And this will be the tax day live stream. I think it's pretty cool. It's the stream is to help everybody forget about having to have their taxes done by today. Although, because of the whole pandemic crisis, we have some extra time. And I'm taking advantage of it too. So welcome, guys. Welcome to the live stream. This is Venus on the screen that you can see right here. It's sitting there Venusing, doing what Venus does. I ran head on into the misconceptions of what people understand about our solar system. Last time I showed Venus, I had someone write, and it's in the comments of the stream. They said that's not Venus. That's not what it looks like, and they linked a video that they did, which unfortunately was an out of focus video, and I'm certain it was a Venus. But when they told me what camera it was, I knew exactly what the problem was. They were using the Nikon P900, a fantastic camera. It's one of those super zooms. I have one, and it looks like a digital camera, like a regular camera. You just can't remove the lens, but it goes out about, like 6 feet from the camera. When it extends, it looks like it comes out really far. That's a joke about the distance. But so when I was looking at the image, I noticed, he was probably zoomed in on a tripod and all. And the problem is that the P900 camera can't focus on Venus properly. Not because it's Venus, but stars in general. It's not a camera made for astrophotography. He said the shimmering of Venus indicated, water, you could see water. And it's like, no, that's actually, I was very kind because I recognized that the failure wasn't his. The failure was the education that he had in school. I said it was atmospheric scintillation that he was looking at, which is the turbulent atmosphere causing problems with your image. So that was actually the issue. And I gave him links to show him what Venus looks like in the various phases, and right now Venus is sort of coming toward us in its orbit, I believe. And as it approaches us, it's going to end up getting bigger and bigger in the sky, but paradoxically going to become a little bit more faint. So it's kind of an interesting thing. We're going to be looking at the backside of Venus because it'll be between us and the sun.
There will be kind of a happy medium with Venus in the coming weeks. The crescent is going to get skinnier and skinnier as it has rounded the corner and is coming closer to us. When the phase angle between us and the Venus and the sun changes, it's going to get skinnier, but it's also going to get bigger.
That's right.
And at some point, it'll hit the happy balance between size and width or lack of, and it will be at its brightest at that time.
Yeah, then it's going to start getting dimmer even though it's closer to us.
Yes, just because the crescent has gotten so skinny, there's not as much surface area to reflect from.
That's right. And then people say, well, how come we never see Venus fully round? And I explained in this comment, which is actually on that SkyTour LiveStream video. I said, well, we can't see Venus when it's round. Like when it's on the other side of the sun, because we'd have to look through the sun to see it. Because Venus is sort of in the plane of the ecliptic where we're in, the same plane we're in, roughly. And so we're not going to see Venus when it's round. We see it always as some phase near full at the most. And then it gets too close to the sun to image it at all, except perhaps from space.
I didn't know that. Where was I that night? How could I not have known that? How could that never have come up before?
Oh, well, I guess because we haven't been imaging Venus in SkyTour LiveStream, or else I would have spilled it over into SkyTour Radio, probably. But you're right,
I guess I never really thought about it.
Yeah.
Are there any other planets like that?
Yeah, Mercury.
I was gonna say maybe Mercury because it's further out, closer to the sun.
Yep. But this is only for planets that are closest closer than us to the sun because
between the sun and the Earth.
yeah, and Mercury and Venus are the only planets that will show us phases like the moon. Okay, and that's because they're closer to the sun than we are. And if you were in ancient Babylon and you looked at Venus and you could tell that Venus was showing you a phase like the moon, then that would be pretty puzzling to you if you thought the Earth was the center of everything and that everybody else went around us. Because that wouldn't make any sense. You wouldn't get phases like that if the sun revolved around the Earth, and orbited the Earth like and then like if Venus also orbited the Earth and Mercury orbited the Earth, you wouldn't see that. So it looked pretty strange for the course of the year. They couldn't put it together; it wouldn't work. So they tried to fudge it, but it didn't work. I mean, that's what Ptolemy, was it epicycles that Ptolemy had that he was talking about?
Yes.
And the epicycles were meant to explain that, but that became too cumbersome. It was. But again, it's cumbersome in the same way that in the modern world, we use something like dark energy to explain something we don't understand. We call it dark energy because we don't know what it is, right? Well, it's something that is causing the universe to apparently accelerate as it expands outward. However, a paper that has just been submitted to the Astrophysical Journal says that they're not finding the acceleration that dark matter should be responsible for. And it's calling into question dark energy is responsible for, and they're calling into question whether dark energy really does exist. So, even the greatest minds, right?
Yeah. Dark energy, dark matter, they're just placeholders, they stuck a name on it, and, nobody really knows what it is, but the name stuck, and now everybody thinks there's some dark energy and dark matter floating around out there.
Well, I mean, dark just means we don't know what it is.
How would you describe what it really is, though? Just matter we can't account for?
That's the
matter we can't account for? Or?
Yes, it's matter that must be there that we can't detect directly for dark matter, and dark energy is energy that pervades the universe and actually forces space apart. All right, and everything in space that is within the space, like galaxies and so forth, and thus they go too. So that's the idea, and it's called dark because we can't really detect it. We only see indirectly how it's working. And the difference between dark matter and dark energy, which is exactly what the question was from Rockstar, is that dark matter came about because we noticed that galaxies don't rotate the way we intuitively thought they may, which is like our solar system works. Mercury speeds around the sun because it's closest to the sun. Pluto lazily goes around the sun in several hundred years because it's so far out. So we thought stars closer to the core of a galaxy would go spinning around the core of the galaxy faster than stars on the outskirts. Well, the observations were not exactly that at all. In fact, galaxies, to an order of processing in your head, rotate like a rigid disk, meaning that the stars on the outer edge are zooming along at immense speeds relative to the stars in the center. Exactly the opposite of what it should. And the question was, is this breaking Newtonian kinematics? Is this physics breaking down by what we're seeing here? I know you're looking at my cursor, sorry. And the answer is that no, it isn't, because they said if there is a giant halo of matter we cannot see surrounding the galaxy, then its mass could cause the rotation that we see, and it actually matches pretty well when you go through the models. Now, is that a matter of or people just looking at the observations and putting a model to it and saying, oh, this makes it work? Maybe. So the question is dark matter real? Well, we're hunting for dark matter too. We're hunting for dark energy as well. And not every study says dark energy isn't there. there are some that say it is, and some that says we're not sure. Okay, I mean, that's kind of where it is. It's not saying it's not there. It's saying we're not sure. Well, the funny thing about this is that when you look at dark energy now, you look at dark energy, and this is what's responsible for making the universe expand at an accelerating rate. When you have a Big Bang, the acceleration from the Big Bang stopped very, very soon after the Big Bang, and everything was just cruising out now. But something is causing the expansion to accelerate. And we found this because when Edwin Hubble in the 20s was looking at the galaxies and their redshift, that is the rate of recession, the speed at which they're moving away from us, he found that the farther they were from us, the faster they were moving away. And this went into a cosmological model that modeled how the universe was built. And when he came up with a constant that he saw, and this constant showed that the rate of expansion was this value that seemed constant everywhere he looked. And that's the key. I'll come back to that. And so that became something called the Hubble constant. Well, as we saw in the last year or two, there has been research to show unequivocally that the Hubble constant isn't a constant. And in fact, the Planck telescope seemed to indicate that the constant doesn't exist at all. In fact, it's just a parameter. And that parameter is a parameter of acceleration, showing that the universe is actually accelerating outward, okay, going faster and faster every moment. Kind of an interesting thing. Now, I talked about this thing with Hubble. When he came up with this Hubble constant, he was looking at all these galaxies in all directions. The problem is, we find that this acceleration, and this is one of the papers that has just been submitted. I don't know if it's Astrophysical Journal or another one. It could be Nature. I'm not sure. I'll have to look. But we found that the acceleration isn't the same in all directions. So this is breaking one of our tenets, TENETS, foundational understandings, one of our tenets of the formation of the universe. And that is that the universe was clumpy when it first exploded, but the acceleration was constant. It was homogeneous in all directions. That's what we thought. And the studies are seeming to indicate that the universe is not so much an expanding sphere, but maybe more of a blob, of various size blob that's expanding in a number of directions differently than in others. So you see what's happening here? This is crazy, and it's really becoming, the universe is becoming quite unwieldy, darn it all. I think it needs to sharpen up and fly right, Straighten out, man. Straighten out, universe. Give us something we can understand, will you? But so the whole matter of dark energy and dark matter, as Daryl was saying, he's not on board with it as much. And I've just been following the research and saying, well, look, here's what the research says. So for now, until something else comes along, we will tentatively run with this. And we have. And as it becomes unwieldy, we will probably, not change our thinking on it. But anyway, that's the story of dark matter and dark energy. Daryl, you have anything you want to add?
Well, I want to talk about Venus some more. Okay, I'm old school. I'm like Hoyle in the steady state theory, when the Big Bang came around. To me, this all gets to be like how many angels can dance on the head of a pin. Show me otherwise. I'm really not interested. I think people are way too dependent on models nowadays. And that's really all I have to say about dark matter and dark energy. As for Venus there, which I still see on the screen.
Yes.
When Venus first comes out from behind the sun in its orbit, and we see it up in the southwestern sky after sunset, Venus is pretty round. Okay, it's so round you couldn't tell the difference that it's not truly, uh, spherical, spheroidal, whatever.
Yep.
And then as it comes around its orbit, it starts getting skinny. It's kind of a lozenge shape. And as I said the other night, when Venus is at its easternmost elongation from the sun in the sky, when it turns the corner in its orbit, as seen from Earth, we see Venus as half lit. And from that point on, it's starting to move toward where it's passing between Earth and the sun, and it gets bigger and bigger and skinnier.
Yeah.
It's like the moon phases running in reverse. Now, conversely, after inferior conjunction, when Venus passes between Earth and the sun, well, when we first see it pop back up in the morning sky, say in the southeast, it's still going to be a skinny, big crescent, but the crescent's going to be facing the other way. Instead of facing the lower right, it's going to be facing the lower left. And it will get bigger and bigger night by night as it moves farther and farther away from the sun until it rounds a corner going around to the far side of the sun, at which point we see it move toward being, circular again or spheroidal, whatever.
Yeah.
So it runs like the sun. It runs like the moon, but sort of in reverse.
Very cool. No, that's right.
And as for what you said earlier, too, well, the Assyrians or whoever it was, they probably couldn't have wrapped their heads around that. I dare say some of the ancient Greeks probably could. Aristarchus, he was, I think, the first guy who posited that the Earth orbited the sun, not the other way around, a long time before what's his face did, Copernicus.
Yes.
I dare say there were some Greeks that probably could have figured that out, a couple thousand years ago.
Perhaps, yeah, perhaps. If you think about it, Copernicus figured this all out without the benefit of the types of instrumentation we have now.
Mm-hmm.
Galileo, in fact, posited all this stuff as well. And he had his really crude, primitive refracting telescope. So that was actually the optic tube. I think that was a pretty cool little invention,
Yeah.
Yep. Not bad.
Yeah. And then Newton invented the Newtonian reflector.
Yes, he did. That's right.
And, they were all groundbreakers in their way.
That's right. I mean, his reflector was made of wood, except for the mirror, of course.
Yep.
It was a wooden tube, So, Amanda, did you, I think you put a question in chat, which just took off, and I
There were a few, yeah. Ooh, hold on, get back. When we were talking about dark matter, dark energy and stuff.
Yeah.
Rockstar wanted to know, isn't that what CERN was trying to find? But since we're talking about CERN, he also wanted to know what CERN is actually trying to do. If not, look for dark energy.
You're talking about the Large Hadron Collider, the LHC?
CERN?
Yeah.
Yes.
Is that what that is?
That's where the Large Hadron Collider is, right?
Because I've heard that term before too, and I don't know, I thought there were two different things. I was thinking CERN was something like SETI, that it was searching space for something.
Well, they were looking for, they're doing groundbreaking in the world of quantum physics, because the Large Hadron Collider is in business to smash little tiny particles together and see if something new comes out. And certainly they're finding that there are new particles that they hadn't seen before, and that's the primary reason for the existence of the LHC. But I can't speak to what they're doing this year or whatever, because I don't follow exactly what they're doing every day. But they have a web page, which I've been to a number of times, and it tells you the programs. They're doing many things, not just one. There's a lot of programs that they're doing. So I don't know any specific other than they were looking for the that Higgs boson, They call it the God particle. And, you know, that's something that, you know, that the Large Hadron Collider had so many detractors because they thought that we were venturing into this new territory where we could end up, you know, destroying the planet if we created the wrong kind of particles. But what people don't realize is these particles have a lifespan of nanoseconds, you know, and then they're gone. And you just look at the results in a quote-unquote bubble tank, and you see the traces left by these things. And they tell you, by the way they move, the angle, everything tells you what's been colliding and what has been generated from the collision. Basically, the debris of the collision is always going to be a smaller particle. And they're seeing these smaller particles and they're finding out, oh, look at that. There's some new particles we've never seen before, that kind of thing. So that's the whole point of colliders. We actually had one at my university. There was a particle accelerator there as well, run by T.J. Morgan, a beautiful lab that had a tremendous cooling going on to cool everything down, and had this just amazing setup. And this particle accelerator would do accelerated particle physics too, and TJ was into that as well. Really great guy, really good guy, you know. So, you know, so they're all over the place. You have these little tiny particle accelerators. You probably have one in your backyard and don't even know it, you know.
Okay, so that's the Hadron Collider. What's Higgs boson?
What's the Higgs boson? Higgs boson is a particle that we had to find that would it was sort of a bridge particle. Let me think of a good way to explain it. Trying to think of the way they explain it on their page, because the bottom line is that it's part of the standard model of physics, and it's something that how do I say this? Oh God. All right.
Daryl, you got anything?
It's a boson, okay? And what is a boson? They're particles that are responsible for all the forces in physics, okay? We know that light, for instance, is a boson. There are W and Z bosons. There's gluons, okay? These are different types of bosons. And you have to go through an understanding of all the many different types of particles to understand why the Higgs boson is really a very important elementary particle. You know, it has a certain mass, has a certain energy, and that's very important. It was actually discovered at the LHC between I think 2012. I think it was actually 2011. I think, and so. Yeah, I'm trying to figure out how to explain it in a way that makes any sense.
That's quantum mechanics for you. Huh?
Yeah, right, exactly. That's the thing. You know, if you ask a physicist what the Higgs boson is, he starts writing equations. He or she. Okay, and they show you the result and say that's the Higgs boson.
Math is hard.
Yeah, when you say, well, put it into words for everybody, you know.
Whiny Barbie voice. Math is hard.
Math is sure hard. Well, you know, and of course, compared to other particles, you know, the Higgs boson's really large. Okay, so you would think it's not very hard to detect, but it's actually really difficult, and it doesn't last long either, and that's part of the problem, as I remember. And every time there's a collision, okay, you get many different particles, and you know, like I said, debris from colliding big particles together. They break apart into smaller particles, and the hunt for these particles was, I guess, probably fundamental to quantum mechanics, and so it was probably very important to find this particular one because this one sort of ties everything together. And I guess I'm probably gonna have to do a show on the Higgs boson, don't I?
Ties everything together. Um, well, as I understand the Large Hadron Collider, I mean, you're dealing with, really tiny stuff on a really tiny scale,
Yeah.
and
Short lifetime.
it's sort of at the opposite end of the spectrum from what cosmology or where we're looking at galaxies and pondering about dark matter and dark energy.
Yeah.
But what ties them together? Is that where the unified field theory comes in? I
Yeah.
saw something the other day where what's his name, Wolfram, Peter Wolfram.
Yeah.
He just came out with his theory on a unified field theory.
Oh, did he?
I haven't read the details. I tried; it just went right over my head. But
well, I have to see what he has to say.
It's tying. It's all about tying the really small and the really big together.
That's right. And if you look at quantum mechanics, you have to fudge some things to get it to work properly. If you talk about it in terms of macro models like cosmology, you can't. They don't work together. They don't talk well together very nicely, and that's part of the problem. And we have to get that we have to get that translation in there, and that's something we don't have right now. And that would be grand unified theory. Yeah. Let's see here. I'm gonna bring up this guy, and then this guy, and shut off this guy for now.
Okay, we have some more questions.
Okay.
And sorry, I know these are taking a while, but we're kind of, I don't know, fleshing out a lot of these topics.
That's all right.
It's going way back. James Dugan wanted to know if anyone caught the new Red Dwarf. I have not heard of it.
Oh, Red! I have not seen the new Red Dwarf.
So, have you guys, Daryl or Mark?
Not me.
No, I haven't seen it, but if I recall, the theme song to the show Red Dwarf goes, "It's cold outside." I'm trying to remember the words. I remember the words. It was a really funny story. It's a sort of a spoof satire of space shows. Really funny and really cheesy models. Like I said, I was working on a miniseries over in London, and I opened up this double-walled cabinet, and when I opened it up, the Red Dwarf models they used in the actual show fell out in my hand. I was like, oh, these are amazing. I remember these. And it turns out that the show ended up, doing very well and became sort of a cult sensation, Just a really great show. I have not seen it. I'm gonna start considering bringing us over to the Comet because I'd like to get an idea where it is and what it's doing, and just to give you an idea where the Comet is right now, let's go to my Comet screen that I've engineered here for you guys. I didn't engineer it. This is actually something that's it's something that I brought up that exists already. But this is our solar system right here. And if you look, you can see that the Atlas telescope has discovered more than one comet. Okay, this is Comet C2019 Y1 Atlas. And this is Comet C2019 Y4. Okay, and that Comet Y4 is on its way into the inner solar system. So it's actually got a date with the sun. And if you'll notice, this blue ring here, this is the ring of the Earth's orbit. And Comet Y4 here is going to make its way around the sun. But if you'll notice, it's actually never getting close to the Earth's orbit at all. So we won't have any influence on our orbit by this comet. All right, we won't be passing through dust from its tail unless the dust migrates elsewhere in the solar system over the years, and we'll see it then. But there's a number of comets. Every one of these blue-tailed things are comets that are currently, zipping around the sun, all right, or near the sun. We have Christensen. We have the two Atlas finds. We have Pan-STARRS, and way farther out. Okay, if we zoom way out, okay, you can see that the orbits of the comets take them way out of our solar system, out of our inner solar system and outer solar system. Because if you remember, look where Pluto is, okay? And Pluto is an oddball. Its orbit's tilted a little bit. Here's the plane of the ecliptic, that is. And Pluto's at a little bit of a tilt. And these comets are any old way. It matters how they got wrangled into the inner solar system. But as they come in, we're going to see Atlas, Y4 over here, and we're going to see what it does as it gets closer to the sun. And it'll be closest to Earth, okay, which will be right around this point here, and that'll be 72 or so million miles from us. And then it's going to be less than the distance of Mercury from the sun, as you can see, when it gets to the sun's closest point to the sun on May 31st. So that's going to be an interesting sequence. And then when it comes out the other side, then we'll see if it actually had remained cohesive or not. My prediction, we're going to see particles. We're going to see a train of pieces, maybe 2 or 3 pieces. And when we were looking at Y4 a couple weeks ago, I might have reminded you guys, when we looked at Y4, we actually saw what looked like the comet was fragmenting. And I called it that night and said, I think that the comet is fragmenting. And sure enough, later on when they took better pictures of it with bigger telescopes and so forth, they said, oh yes, the comet is now fragmenting. Well, we caught that. We saw that. And we're not the reason it's fragmenting, and nor did we were the first ones to see it, but we did have the ability to see it in SkyTour LiveStream, which I thought was pretty cool. Daryl, you were in the chat that night, weren't you? He's on mute.
I'm sorry. Yes, I was. Yeah.
Yeah, so you remember that. So we actually, I think I think that's pretty cool.
Yep.
Yeah.
Comet Atlas is probably going away, but hey, there's another comet out there now.
Yeah.
It's called Comet Swan.
Yeah, we don't see it here yet in the inner solar system.
Yeah, it's down in Pisces Austrinus now.
Yeah.
The southern fish, and that's where Fomalhaut is. And it's going to be a May object, but it's going to be in the morning sky instead of the evening sky. And as it gets closer, it's going to move from Pisces Austrinus up through Triangulum, I think, and into Perseus.
Okay.
Perseus is setting or has set in the evening sky.
Yeah.
But, it's going to be popping up in the morning sky by next month. And,
sure.
So Comet Swan will be moving up from the south where we get a more favorable view in May.
Nice.
And it's kind of going to be a sub for the late great Comet Atlas.
Yep. I think that'll be beautiful. I hope we get to see it.
Yep, me too.
Yeah. So I'm thinking what we'll do is I'd like to go get the orbital elements of the comet, and then I'll plug in its coordinates, and we'll be able to actually go out and find the comet, Atlas Y4, like we have each and every night so far this week. I think that we have had clear nights. I think that's going to be a cool thing to do again tonight.
Comet Swan was discovered by the Soho, too, by the way. We talked about that just recently.
Yeah,
Amanda, you might remember we talked about sun grazer comets and stuff, and I showed you some Soho images of it. Yeah, so Comet Swan was discovered by the same Soho satellite.
Very cool.
And we still have questions, guys.
Okay, go ahead.
And I do have everyone's questions. It's just taking a while to get to them, so please be patient. Okay. Genghis said he saw something about NASA wanting to put a telescope on the far side of the moon. Has anyone heard anything about that?
Yes.
And?
I can't.
That'd be cool. No?
Great detail. Yeah, I've seen a couple articles about it. If it's the one I'm thinking of, I suspect it is. It would be a radio telescope, and it's sort of like the Arecibo Observatory down in Puerto Rico, and China has now built one like that too, but bigger than Arecibo.
Right, use a crater as a natural bowl.
exactly. They want to string up sort of a giant radio antenna in a crater on the far side of the moon where it will be immune to interference from Earth radio and stuff, and they'll use it to go out and look at things in radio wavelengths.
Yeah, which would be good because then if they see something that looks artificial, for instance, they can't say that it was something from us, except there are a number of probes in orbit around the moon as well. So they'd have to make sure it wasn't one of those.
Yeah.
Yeah.
Because I thought I heard China doing something like that, but did something happen on the way where it didn't land properly or didn't make it at the last moment or something? Or am I thinking something else?
They have a lander on the far side of the moon. I don't know if it's still working or not. I assume it is.
Oh, the Chang landers, yeah.
Yeah. The idea of a telescope on the moon is nothing new. I remember when, 50 years ago or more, Arthur C. Clarke, the guy who wrote 2001: A Space Odyssey, he wrote a story about telescopes on the moon.
Yeah. That's another example of, looking forward, forward thinking, Well, what we'll do now is I am going to take us over to the Comet. All right. So we will go back to our non-cometary view right there, and I'll bring up our observatory cam, live observatory cam, so you can follow along as the telescope begins its trek. And
Charles wanted to know what you guys thought of all the observatories shutting down.
Well, is it just because of the virus?
I think so, yeah.
Yeah, well, luckily the asteroid hunting systems are not shutting down. That's the one we would worry about, right? If we just go blind, basically. We want to be able to see if there's an imminent threat heading our way. But again, it's like doctors' offices shutting down for a period of time. It's temporary. And we got to be careful not to let any conspiracies take root, because I think when there was a solar observatory that shut down, and they said there was something untoward going on there, and then they said another one shut down. What are they hiding? They weren't hiding anything. They were hiding a scandal within one of the observatories. They weren't hiding it, but they were processing the person that had been going online and doing surreptitious, going to surreptitious sites that are less than reputable, which was kind of embarrassing if you think about it. But
hey, Rule 34, man.
What's Rule 34?
Well, if you don't know, I'm not going to tell you.
Oh, okay.
We have ladies here. Rule 34 says that anything can and will be made porn from.
Oh, I see what you're saying. Yeah, I guess that's true. Telescopes are unfortunately easy prey, easy targets. Okay, I've got the coordinates in for the Comet, and we're going to say go to. Now the dome is going to be, I'm going to have to move the dome. So we'll just live with that, but watch the telescope move over here. There it goes. And here you hear it now. And it might, I probably shouldn't have told it to go until I moved the dome, because that's what I say. That's what I don't like. The dome isn't motorized, and it's supposed to be a roll-off roof. It should be, because that way none of this would be a problem. I would never have to go out there. So it's going to try and go to where the comet is, and as you can see, it's going there, but it's facing at the dome. So not going to be able to see anything here yet. So I'll be right back, because I have to do my duty. I have to go out and move the dome. All right. So would you keep everybody enthralled, Daryl and Amanda?
I'll try.
I don't know if I can keep them enthralled, but...
Oh, yes, you can. All right, I'll be right back.
I'll be here,
Let's hear it for
Hello,
those two.
Ronald. And hello. Who else did I see? Marianne, hello. Hi, Amanda. How are you doing?
Hi, Daryl. How are you? I'm well. How are you?
Oh, I'm hanging in there. I had to go to Walmart last night to pick up the prescription, and I was dismayed. It was 5:30 or so. I mean, the place was really busy, and there were less people wearing masks than there were not wearing masks, and I found that kind of distressing. Plus, I got to wear my mask for the first time last night.
Yay, how did it work? How did it feel?
It was okay. I don't know what it was, if it's the weave of the cloth or what, or just the dynamics of the social distancing and the situation at the time. It was almost like I was feeling claustrophobic, and I was having a hard time getting my breath through that mask.
Wow.
It was weird. But hey, I looked good. It's a cute mask. Sister sent it to me. It's, regular cotton face mask, and it's got drawstrings tied behind your head, and it's blue, and it's got clouds, and it's got stars on it, and I guess that was quite fitting,
Yeah. That's pretty.
It is. Excuse me. Oh, golly, what else is going on?
We had another question. I'm sure you can answer it if it's possible. I don't understand it, but I'm sure you would. I think it was when Mark was talking about the comet breaking up behind the sun. Anonymous wants to know, how could plasma disintegrate? Can it?
Well, I'm back. Sorry.
Oh, did you hear that question?
Yeah. Well, plasma is high energy protons and electrons. It's what happens when atoms are put in very, very hot situations. The electrons can't bind and go into the atom and be part of the nucleus anymore, or orbit part of the atom, because the energies are too high, and they can't achieve an energy level in the atom because too much energy is being absorbed by them. And of course, so the solar wind is these plasma, this protons and electrons that are streaming out of the sun and heading toward the Earth. So we see plasma all the time, and it doesn't get destroyed, and doesn't disintegrate, but they're protons and electrons, so they will just become part of something else as they slow down and lose their energy. They interact with molecules in the upper atmosphere, and we see the beautiful aurora borealis. I'm just gonna go to Dubai here, and then tell it to go back to the comet, because I'm certain the comet's not in there. It was facing away.
I would assume the plasma, I mean, it will cool off, and eventually probably just the electrons and protons, whatever, will recombine.
Yeah, we'll see recombination occur, and that's kind of what happens, right? So.
Yeah, I showed you some coronal mass ejections images the other day, Amanda, if you remember that. And yeah, I guess you could say that's just plasma too, isn't it, Mark?
Coronal mass ejections are going to be plasma, yeah.
Yeah.
Yep.
And when they hit the Earth, they make northern lights and southern lights, and
that's right.
Sometimes they knock out power grids.
Yeah. That's
the so-called Carrington event.
Yeah, and you know what's funny about that? When they strike the Earth, the salvation for every life form on the planet has been that the Earth has a beautiful magnetic field. This is the N star in the bowl of the Big Dipper right here. This is Dubai, which you can see here. Okay, and we're going to use Dubai as a starting point, and from there we're going to make our way back to the comet, which, if you ever want to find it with binoculars while it's still in existence, then what you'll do is you'll see the N stars in the bowl. Here again, here's the whole Big Dipper right here. Here's the tail and the handle and the bowl of the Big Dipper. And those two stars at the end point to Polaris. So when you see those two stars, you go about halfway between, and you go over by about the length of the entire Big Dipper. Okay, away from the two constellations. So you go away from them, and it'll be right about here. You'll see a fuzzy spot, and that will be Comet Atlas Y4. All right. So now let's go back and tell us to go to these coordinates again. Now that the telescope can see the sky, and the telescope's first going to go to a star that will be what it's considered a bridge star that's going to make it a stop off point, and it's going to make it a let's see where we're going here. I'm sorry, I'm just trying to figure out where it went. Oh, it did that last night. Yeah, it went to Mancalanan. So that's over in Auriga. So it went all the way over there, and at least we can see it, which means that the guide star is being seen by the guide star finder as well. And then it'll center it, and then from there it can make its way over to this location in between, which is right about here. All right, and you'll see the little telescope indicator making its way. Yeah. And there are the stars showing up here. These are stars in the field, and we should see the comet when we image this. And we're ready. So I would think that by now it has managed to find a guide star. So let's go up and just do let's do a 10-second photo at 10,000 ASA or ISO, okay? That's sensitivity. This is just a little finder shot just to check it. I could go to the 4K video, but it's so faint that I don't want to hunt. All right, so we're doing it now, and we'll see the comet. And we'll see how it looks tonight. All right, let's see it. Oh, probably should have gone a little longer. Actually, I'm going to go make it easy for myself. I should have done this before. I'm going to take the filter wheel, and I'm going to drop us to position 5. That's the spectra. And let's do the straight through shot. You'll see more stars now. Kaboom-bee. And then I'll do 10 seconds at 10,000 and see if we made it to the comet. We might have to go up a little bit. So we'll try again. There it is. See, it's so faint that it's hard to see. Well, there we go. We're seeing it again. And so what I'll do is, knowing that we have these two stars, these two field stars, I will, and those are these two field stars, I'll bring the comet over now and get it into our view. Amanda, did we have other questions? I'm sorry.
Not at the moment.
Okay, good.
Keep an eye on chat though.
Thank you.
And I hope Mark and Daryl are answering all your questions. If not, please post more.
Yeah, guys, if you think my answer was pure garbage, just go ahead and say so, and then, blame Amanda. Just kidding. They won't.
No, well, hey, you've said things in the
won't.
past, and if I don't understand, I press you until I do, so...
And that's fair.
Yeah.
No,
And
that's
or
totally fair.
if you have follow-up questions or want him to pursue the discussion a little further, let us know.
Yep.
It's live. I'm keeping an eye on chat, so...
I appreciate
just
what
like
you're
I said, I am getting the questions. Just depending on where the conversation takes us, you just have to be patient. So.
Well, I'm very pleased with what you're doing.
All-seeing activity asks, how about Comet C/2020 F8? I think that is Comet Swan we talked about a minute ago. If so, it is way down in the southern sky right now,
Right now, yeah.
and in the morning sky too. So
We have to wait for it to go around the sun before we'll see it in the night sky, I would think. Is that true?
yeah, it's going to move up from the south, and it's going to be in the morning sky in May.
Oh, it will be?
Yeah.
Okay. Is it only going to be a morning sky comet? Because
that's all I saw.
okay,
With a quick look.
Because it could certainly comets could be evening and morning, or morning and morning and evening. I mean, they could spend their entire existence in one or the other. It depends. When they go behind the sun, though, usually it's a transition that they make toward another time of day when we'll see it. Well, there you go. Here's a nice shot of the comet. Let's take a look at this now.
Yeah, Hale-Bopp was a morning object, and then it went around the sun and emerged into the evening sky, and that's when it was at its best, March of 1997.
Yeah, now take a look at this. I think we're seeing some distinct separation here.
Mm-hmm.
I think we're seeing several objects. This one I think is actually a digital noise. But look, I see 1, I see 2, I see 3, maybe 4. Do you see those?
Yeah. Yes. I believe I sent you a link to an image.
Yeah, I
this
mean
morning
it's
or
clear.
yesterday
Look at that.
They estimated the spacing between those the fragments on either end to be about like 3,400 kilometers apart.
Yeah. And in the sky, they actually approximated a few arc minutes. But look at that, guys. You can actually see the separation between these components. That is outstanding. Now we can work with this, because now what we can do is we can refine our exposures and drop down until we actually get an exposure that might show us better these components. Very cool. I'm liking this. This is a good thing.
Okay, we have a few more questions coming in.
Sure, go ahead.
Our good friend Marianne Robb. Hi, Marianne.
I know Marianne.
She wants to know if we can zoom in a little more. I don't know if that's possible.
Yeah, once we take the photo, we can.
Okay. And Anonymous wants to know what the current brightness level of Y4 is.
I saw earlier today for that, Comet Atlas had been up around 8th magnitude, and I think earlier today it was like it's dropping rapidly now because it's breaking apart.
Yeah.
It was like magnitude 9.4 or something of the sort.
Yeah. So the fact is, this comet is not going to become a comet of the century, so to speak. However, one of the things that the comet is going to be is remembered for the fact that you can actually see the separate components. And this is not it. This is an error here. I actually had
bumped or something.
It wasn't. It was actually the guide scope made an error, but it's kind of interesting nonetheless. It's a really interesting.
It's crazy that you guys know those kind of things.
No, I mean, if you look carefully, you see it has these different segments. Okay, those different segments tell me something about. This is the guide scope trying to correct, but it's overcorrecting, which is telling me that I have too much throw, so to speak, in the correction. So what I'm going to do is I'm going to go to that, which is there, and then go down one level, and go down another, and say enter. And now I'm going to set up what's called the red ascension correction, and I'm going to add a 5 is going to be the correction amount that I'm going to have it add. And I'm going to go down again. I'm looking at the hand controller in my head right now. That's what I'm doing. And I'm going to hit enter and enter the declination correction, which is only going to be, instead of what it was, which is probably 66, I'm going to go down to 1 and enter, and then pop out of everything. And now, if we do this same shot again, actually let's do 30 seconds just to make it quicker. we should see it looks different. So, yeah. Anyway, so we get some pretty wacky shots at times. But this is the shot I think that's important, and this is the one where you can actually see the separate heads here, the separate elements that broke apart in this comet. Really kind of fascinating. And if we can actually get this down to where I can get rid of the noise by taking a longer exposure at lower ISO levels, then I think, this is better. Look at this. Let's check this out. All right, let's get in here. Yeah, look at that. You can clearly see the, this is looking a little different. We probably have to go a little longer. But you can see the fragments in there. Holy cow. Boy, that comet's not the place to be right now, I can tell you. But that's something.
I have another question.
Sure, go ahead.
And I don't even know how you're going to begin to answer this. Do comets come from the beginning of time?
They come.
How do you even begin to answer that?
Well, we do though. We know how to answer that question, because when our solar system was formed, the solar system was originally part of what's called a solar nebula. Before there were any planets, there was gas and lots of dust. Why dust? Well, it came from the processes in stars in the past. Supernovae had liberated, and when they exploded, they liberated many kinds of elements that we see in our periodic table. Everything from hydrogen down to plutonium, for crying out loud, and other elements. And these heavier elements like the zinc and the silver and the gold that comes from collisions of neutron stars and other things, all of the stuff in the populated in the periodic table gets populated by the stellar nucleosynthesis and processes of collisions. So we had a lot of material hanging around, enough to make lots and lots of planets. So you can see that it was a pretty hefty size dumping ground of materials that the sun managed to hang on to and capture. And because they clumped and so forth, they got a little clumpy at times, and these clumps grew bigger and bigger and bigger individually, and these became the planets. And over time, and it was a lot more chaotic in the early solar system. There was probably more than one Earth-sized planet in the inner solar system, besides Venus and Earth. There was probably several more. And over time, they were redistributed, collided, smashed to bits, and when the solar system finally settled out, okay, the inner solar system looks like it does, and the outer solar system was a little different, but the planets migrated to their final orbits over time. But way back in the beginning, when there's all this debris from collisions and so forth, this happened in the inner solar system, it happened in the outer solar system, it happened out in the Kuiper Belt beyond Pluto. We had all these particles and all this debris that clumped together and started coalescing. So we had asteroids that formed that were nothing more than gravel piles held together. Asteroid Bennu is a good example. When you see that, OSIRIS-REx is at Bennu right now, and the Japanese actually landed on Ryugu, and it got a sample of Ryugu, which is also possibly a gravel pile asteroid. Literally a tenuous collection of gravel held together by its own mutual gravity. And farther out in the Kuiper Belt, we have icy bodies that formed out there. And this all happened at the early stages of the solar system's formation. So yeah, comets are from effectively the beginning of our time. Not the beginning of the universe, but the beginning of our time. All right? And the elements that make the comets, well, those could actually be from anywhere along the way as the universe aged and having migrated here. So they could have come from a variety of sources. See what I mean?
That's very cool.
All right, I'm going to do 1 minute now on this, and I'm going to see if we can leave it at 5,000. I want to try and pull out these these pieces. Those look beautiful. You can actually see the pieces there in the nucleus. You know what's weird? This song right here playing. For those of you out there, there's a particular game that one of my sons used to play a lot called Minecraft. And it sounds like the music from Minecraft.
I can barely hear the music.
Oh, well, yeah, I can see that could be true. However, I think that it's really kind of interesting how the music reminds us of other things, you know? So
it's funny. I just saw a video earlier today. I guess I don't know anything about Minecraft, but they programmed it so like every block played a different musical note.
Oh, really?
And they played a piece from Paganini.
Okay.
Yeah. And
okay, this one didn't work.
he was pretty quick and yeah.
Wow.
Interesting.
We're gonna take another one. We're trying to get that one or two or 7, 10, 20 good shots. I'm just gonna do a couple shots here. Oh, and we are looking in white light at the moment. We're actually looking at the slightly wider narrowband filter view. Daryl, were you... I shot the Orion Nebula before it set the other night. Were you around for that one?
No, but you showed it again toward the end of the stream, and I saw it at that time.
Okay. Because it's for nebulae like that this narrow quad band, it's called, filter really, really excels. You can actually see tremendous differences really, really easily in that quad band view. And a quad band filter, when we talk about narrow band, if we take a picture with a camera, it's a little better, but I have to do this one again. If we take a picture with a camera, we'll see that we have, with a regular camera with nothing, we'll see that we get all the light from the spectrum. But some objects give off light in a specific part of the spectrum, like the Orion Nebula. Okay, the Orion Nebula is giving off light that happens to be in the region that's partially bluish green, kind of like this here on the screen, the comet. And that's oxygen 3. All right, but there's other things which make green colors as well. It's not just oxygen 3, which is doubly ionized oxygen. But also hydrogen gives off that characteristic red glow, the hydrogen alpha. The H2 regions, the regions in space that are stellar nurseries, and that red glow is ionized hydrogen region. We call it H2. And you might say, well, why the 2? Why are you saying H2 when it sounds like it should be H1? Ionized hydrogen should be H1, and doubly ionized oxygen should be O2. Roman numeral 2. Well, the answer is that when an atom is in its base state where it has all its electrons, that's the Roman numeral 1 state. So O1 is at the point where oxygen has all of its electrons. Okay, so ionized oxygen will be O Roman numeral 2, so OII. Okay, and so doubly ionized is OIII, O3. So that's the convention. I know it's kind of tricky, but that's what it is. So the filter, the quad band, narrow band filter, is looking at narrow slots in the spectrum for this oxygen 3. Here we go. That's a good one. And it looks in this part of the spectrum that shows us only oxygen 3 and sulfur 2, which is, of course, singly ionized sulfur, and H beta, okay, and H alpha. So kind of oxygen 3 and H beta kind of near the blue end, and sulfur 2 and hydrogen alpha kind of more toward the red end. Hydrogen alpha very red. All right. So here we go. This is another shot. This actually, we can see the head of the comet here, and it's kind of tough with this star in the way here. And I think that's also a star in the background as well. And so we actually have to wait for the comet to be here in a little while. And when we take a photo of it in just a little while over here, then it'll be clear what we're actually looking at. All right. I think we have to also make note of the fact that that little red thing you're seeing there, okay, notice how it's not out of focus, okay, but this stuff is got a little walk to it, a little tracking error. That tells you that it's a camera artifact, okay. So that's a camera artifact, but this here and these are stars. We have to wait for the comet to get out from behind there. All right, and that will tell us something else. I'm just going back to look. Yeah. So we need to give it some more time just to see what we're looking at. But very cool stuff, man. I'm really pleased with it so far. What do you think, Daryl?
Yeah.
You know,
Let it move a bit and see what moves with it.
yeah.
Will you excuse me a moment, please?
Yep.
We have another question.
Okay, sure.
Okay, from D. Vincent. They want to know, since it's fragmented, trajectory of these little mountains will pass safely? Is it too soon to anticipate the course of each of the 4 sections?
That's a very good question, D. Vincent, and I want to thank you. And by the way, welcome to SkyTour LiveStream. I don't remember if you were here last time. I think you were.
I've seen the name a few times now.
So
I think they're maybe a newer member or just
Yeah.
someone that's maybe come out from the shadows.
Yep. And I'm kind of going against my tradition here. I'll answer your question here in a minute, D. Vincent. I usually welcome everybody by name, and I will do that soon. I just wanted to get this going and get underway because we had quite a lot to do to get the stream underway tonight. We have 53 people watching right now, and I think that that's really cool, and I welcome all of you. And this is a slightly longer time. We went, sensitivity. We went from a sensitivity of 5,000 to, I believe, 8,000. Let me just make sure. No, 6,400. But I'll go on the next one. I'm going to go up to 8,000 and take another shot. We're now testing how far we can go before we get too much digital noise. Okay, what's digital noise? This stuff, this modeling in here is digital noise. And as I said before, these are stars in the background. Okay, that red thing is an artifact. Then the proof is when we look at other photos, we don't see the red thing. Okay, it comes and goes. See, it's in the same place as the comet, but in the later photo, the comet just happened to be higher. I moved it a little, or it moved in the view when I moved the telescope. So this red thing is just an artifact that we would have to get rid of. So anyway, to answer your question, and what was the question again? Oh my gosh. Amanda?
It was, sorry, I'm coming off mute. Too many screens open. Is it too soon to anticipate the course of each of the 4 sections?
Yeah, no, that's a very good question, actually, as I said.
He said sections. I wanted to say fragments. I got tongue-tied.
That's okay. Call them fractions or something. Combine the words. We kind of know where they're going to go because they're all relatively gravitationally bound to each other. But they're moving through space on a trajectory, and as they do, and they fragment, they're all moving along the same orbit. So they're going to go around the sun, swing around the sun, and come out the other side, kind of in the same general way that they entered, like they are now. But they will either be melted away or evaporated away over time, or they will end up becoming something like a contact binary, where what's that? That's where two objects that are closely orbiting each other, if they manage to contact each other, then the collision will heat them up right at the point where they collide, and then because of the cold of space, right, they will actually freeze fairly quickly again, and they might actually re-cement themselves to each other. We've seen that a lot. There's contact binaries out there in the Kuiper Belt. We just visited one by chance called Ultima Thule. Yeah, very good.
I was just thinking that when you said that they were going to freeze and join again. I was thinking that.
Yeah. That's right. So, and then that they formed a contact binary way back in the beginning, and they're kind of little pancake-shaped. They're more flat objects that ended up touching, and when they touched, they ended up cementing themselves to each other. So here's the comet. Again, that's a star. Okay, right there on the background. We're seeing through the comet to the star beyond. And if you look at successive shots, you can see that the comet has moved a little relative to that star, which has not. Now, I got a question, and that is to Hadley Scott McIntyre. You said, are we going to get scatter? Please refine that. Tell me what you mean by that. I'm not sure what you mean by scatter. Charles Smarr asks, says the comet moves back out into the cold. Can it reform by its own gravity? Well, it's possible that if the fragments survive going around the sun, that the mutual gravity might pull them into each other again, where they would possibly cement themselves together through this contact process. And then it would be like that for another 6,016 years, which is the orbital period of this comet Atlas Y4. So it's possible, Charles, that could happen. Another possibility is that as they emerge from the other side of the sun, some of the pieces might be affected slightly differently than others, and they might separate from each other because they do have momentum and their own moments of inertia, that is the resistance to movement because of their mass. So it may be that they won't come right or they won't cement back together. They might actually separate from each other a little bit, but we don't know. But one thing we're going to get is debris, and we're going to see that now. Actually, we see some of it here. Some of this is the coma material, that is to say carbon atoms like carbon monoxide, which is CO, carbon and oxygen. And much of it is cyanogen, CN, carbon and nitrogen. Cyanogen, of course, like cyanide, is going to be it's a toxin to human life, of course. And we won't go into Camille Flammarion. We did last time, but that was he said that if the cyanogen or cyanide reached our Earth's atmosphere from a comet tail, like Halley's Comet, when it reappeared some years after he said it, it might kill all life on Earth. He opened his mouth without doing his due diligence, but that was in the 1800s when they really didn't know a whole lot about it. So, yeah, that's unfortunate.
They didn't realize that that's basically a pretty good vacuum out there.
Yeah.
It's not like big, huge, thick clouds of gas that we're going to fly through. I mean, there's gas out there, but it's a pretty good vacuum all on its own. Yeah, it's actually, there's a word for that. We call it rarefied, and that's the word that Daryl and I have mentioned a number of times. It's rarefied gas, which means it doesn't have very many atoms per cubic centimeter
of space. It's really it is a vacuum for all intents and purposes. So that material could never harm life on Earth, no matter in that density if it came through. So that's, but you know,
it makes a good story though.
That's right. And as you said, Sir Arthur Conan Doyle, the name you forgot yesterday, right? Or the day before.
Yeah.
Sir Arthur Conan Doyle. I made a point
Guy
of
who
making.
wrote Sherlock Holmes.
Yeah. He actually wrote a story about that, didn't he? You said.
He did. Yeah, I forget its name. But yeah, I mean, you know, here come the comet, and we flew through the tail, and it supposedly killed a whole lot of people, but then they all came back to life after the comet was gone, or they all woke up, or whatever you want to call it.
Was that a? Oh, that was. Are you sure that wasn't a bad B movie that I saw? A very bad B movie.
Well, whoever did the bad B movie, I mean, maybe he read Doyle's book.
Yeah. Now I've gone up in the exposure a little bit here. Not the exposure, but the sensitivity. And now you can actually see that greenish blue coma making an appearance. And the best way to see it is to look at the comet and then look over here. And then out of the corner of your eye, you'll see the color rendering better. The color receptors, you have a cluster, of course, near the center of your eye, but then you have another ring of them just outside that area, and then you have the black and white receptors at the very edge, so that your peripheral vision is best in black and white and at night. So I think it's pretty cool. I really think that it's interesting how this comet has changed drastically from when we first saw it.
Yeah, it's moved to the right quite a bit too.
Yeah, and actually, if we go back to here, here's an image of it a little earlier. Okay, and now if you notice, okay, here's the front end of the comet right there. If you'll see right there, okay, and then you see it's a little farther out. So it's actually moved quite a distance.
We're getting some more questions.
All right.
Hadley, to clarify, asked if we're gonna get debris. That's what they meant by scattering.
No.
Oh,
probably not.
Well, not here at the Earth.
I wonder if they're thinking like asteroid shower, like a meteor shower. So that's what I was wondering.
Yeah, I suspect that's what they're thinking. Mark, you showed a diagram you had inserted. There you go, right there.
Yeah, this is the one I'm bringing up. I think
I'll be right back, guys.
Okay.
You see, it's not anywhere close to Earth's orbit, so no, it won't hit the Earth.
Yeah, let me show you guys. This here is Y4 right here, and here's its orbit. You see that? It goes around the sun and then out the other side. This is the Earth's orbit right here. The blue, this nice light blue, life-giving ring. Now watch this orbit as I move it around. Okay, see that? The orbit comes down from the top, so to speak, and then goes out the bottom. And we don't ever see that comet near the Earth's orbit. So the debris that's left behind by the comet, when we pass through cometary tails at some point during our year, we get little bits of particles and debris that enter our atmosphere and cause a meteor shower. That's where meteor showers come from. This shows you how this particular comet, Y4, will not be giving us any such show. Because if Earth's orbit is here, all right, as you can see, Y4 comes down from the top and goes out the bottom and doesn't ever skirt anywhere near the Earth's orbit. So I'm afraid this orbit, this comet, is not going to deliver any such light show for us. Sorry. I prepared this little 3D thing, which is online at skylive.com. I prepared that for you guys tonight so you could see in a real 3D view of the universe, of our solar system too, how this works. All right. So if you have any questions about that, we can always go back to it. Okay, so let me now go to our view here. Yeah, well, as you can see, we're trying to, I'm trying to actually grab another good shot here of the comet. I actually think I can, I'm going to change a parameter again here. Let me just do this. I'm going to change a parameter. So I'll come in. Go ahead.
I'm sorry, Daniel Whitaker, also the Eta Aquarid meteor shower, which is happening pretty close with the Lyrid meteor shower, is also from Halley's Comet. And Carol, thank you. Yes, the Poison Belt. That's the name of the story.
What is it?
It's called the Poison Belt. That was Arthur Conan Doyle's story.
That was Doyle's story. Okay, yeah, neat.
Yeah.
Very
Carol
cool.
looked it up first.
Thank you, Carol. There was another really bad science fiction one I was thinking of called Night of the Comet, and I think another one of our watchers posted that link, or not link, but that information as well. But Night of the Comet was a real cringeworthy show. It was very poorly done. I can't, But hey, you know what? It was bad science fiction, but it was all we had, man.
I think I managed to miss that one.
You managed to miss that one?
Yep.
Yeah, that's a little, you're being a wise guy, Daryl. Yeah, you managed to miss it, huh? Well, I managed to see it, and I wasn't better for it, but it's okay. All right. So,
it's amazing how often you see bad astronomy, bad science in movies.
Yeah.
Michael Biehn, who played, what was his face in the Aliens sequel?
Yeah.
And he was in Tombstone and a lot of other movies. He did some movie like that once where some comet or something was coming to hit the Earth, and he was an astronomer, and he was supposedly in an observatory, and it was just all really poorly done. But, hey, everybody needs a job, so I guess he did the movie.
Yeah, I guess so. Well, while we're waiting for this exposure to come in, I just want to say hello. Well, now, of course, it comes right in. But I want to say hi to the people that have joined us here. You guys are great. I want to say hi, of course, to Carol, to James Dugan, to Ronald. And we have Genghis and Keith from P&K Space Imaging. Definitely a channel to subscribe to. And D. Vincent W., thank you for all the wonderful questions and so forth. And I want to say hello to My Daily Side, Daniel Whitaker, and I'm going down the list here, sorry. D. Smith is here. You guys are just, you're legend, I'm telling you, and Bill Doucette is hanging out. Hadley Scott McIntyre is in the house hanging with us, and we're having a good time here. Charles Smar is out there. He's orbiting his house right now, asking questions of us right now, which is really kind of cool. Thiago is down here. Thiago Vidal. That's cool. Thiago, are you from Brazil? That's the question. And we have Bara Nasser's here as well. And I remember Bara from the other night. Thank you for coming back. It's good to see you again. Kat Hobson. My wonderful cat is here. Kat Hobson. She's a real star. She's a paranormal investigator, and she does some really cool paranormal stuff. You guys gotta check her out. Kat, if you have a website, feel free to post it in the link. Okay, put a link out here for everybody so they can go. And Justin Time is here, and make sure you do that, Kat. I'm not kidding. That's give yourself a little plug here. And then we got a few other people too, and for those of you that are newcomers that haven't been here before, I welcome you. And Terry Groff, you're not chopped liver, Terry. I didn't, just because I didn't mention your name already. I actually didn't see your name. So, Terry Groff and I have been friends for many years. Texan, all right, and we've had some fun adventures. I went to Dallas to do a a show for National Geographic, and Terry came out and joined me and worked with me on the set to do that particular show. It was really nice. And then we went out for sushi afterwards, and that was an excellent night. And Terry showed me the sights of Dallas, and it was just a great time. So, he's a good guy, and I want to welcome him. And, of course, Tim F. is here as well. And I guess there's a lot more, too, because, like I said, we're almost at 70 people watching right now. So here's our comet. This is Comet Atlas. Now here is where the front of the comet is. You can see that greenish blue glow. It's more green than blue. The bluish is forced by the filter that we're looking at, but we can see it this way. Oh, and I think I missed Lynch is here, so this greenish blue glow is the carbon atoms that we're seeing causing this, and we'll definitely. Oh, Kathy Prentisak, I'm sorry I missed you too. You were here before. It's gonna go on like that, folks. I hate missing people who spent the time, coming here to look, and I don't even respond. It's like, just kick me in the butt, okay? I'm totally, I'm here for you. You guys are here for me. So the least I can do is mention that you're here. And I like doing so. You guys are all really good. But look at this. Here's what the comet looks like now. If we zoom out a little bit, you can see it sort of in its context. And then if I bring up the planetarium, you can see where it is relative to the Big Dipper and the Little Dipper. This is Polaris, the North Star right here. Okay, that's Polaris. And then up here, we have the two end stars of the bowl of the Big Dipper and the tail of the Big Dipper. The handle's right here and the bowl's right here. And those two stars are the finder stars, we call them, to the North Star. And if you go down just a little bit more than halfway, and then away from both of those constellations, in the opposite direction of the tail of the Big Dipper, or the handle of the Big Dipper, about the length of the Big Dipper, that's where the comet is right now in the sky. To give you some context about where it is. So I think that's pretty cool. And and now we're actually viewing it, here. Excuse me, I'm gonna have to get a drink here. And the comet right now, as far as distance from us, the other night it was 1 astronomical unit, and it hasn't varied too much from that. It's still going to be roughly an astronomical unit from us. Maybe it'll be just a little bit closer, maybe. Right now, its brightness it was around 8th magnitude, which is the brightness scale. The higher numbers are fainter, and you can only see to about 4th magnitude in a reasonable dark sky, and maybe a little more, maybe to 5 in a really dark sky. The comet right now is almost 9.5 at 9.5. It's 9.46. And as far as its distance from us, the comet is sitting, again, it's going to be zipping toward the sun. It's going to actually get closer to us. And like I said, the other night it was 1.00 astronomical units. That's 93 million miles and a little more. But tonight it's 0.9 astronomical units. It's actually getting closer because, and it's going to get to 72.5 or so million miles from us at its closest. So it's actually going to get closer to us. And that'll make it more detailed here in SkyTour LiveStream, if it still exists by then. We might only have some fragments with remainder of coma afterwards, but this is what we're looking at. This is the comet. And incidentally, the light from the sun takes 8 minutes to get here, and the light from the comet is taking 8 minutes to get here as well. Just a little less time than it takes for the light from the sun to get here, because it's 0.9 astronomical units away. So it's like 8 minutes and 16 seconds as opposed to 8 minutes and 20 something seconds. So it's on its way. closer, and it really is a wonderful opportunity that we're being afforded here to actually view this. And this was I believe this was a 1 minute exposure at 10,000. We'll keep taking another one, and then we'll head off to another object and then come back, as I like to do. And tonight's a really nice night, guys, so I could be persuaded to just do one more. You know, let's turn on our all sky camera here, and if we get the all sky camera running, then we can. Yeah, there it is. And now we can take the all sky camera, set up the parameters. Okay, we're going to take continuous pictures. We're going to save each shot. And we're going to auto apply the processing that I determined we'll use. And then we'll take exposures that are about 40 seconds in length. So I'm going to do that. I'll set up the 40. And then we'll say go ahead. And now we're going to get a photo. So we'll be right back to that in a moment. And here's our comet, looking wonderful again. And I'm rotating the view, by the way, so we get it a little better. Okay. Now, compare that to this, okay? And
moved on quite a bit.
Yeah. And to say this. Okay, you see where the comet is there? See the head of the comet compared to that right there? That star? Now watch.
The tail's right between those two stars.
Yeah, now look. Now it's gone down a little bit and moved to the right.
Yep.
Right? Yeah, so we've got... and what's interesting is we may take some white light photos of this too to see if... because the filter is, again, it's a narrowband filter, but it's a wider narrowband filter. So we might be missing some of the detail in the coma here. So, yeah, Mark, just one more, D'Antonio. I was actually telling Carol Carl, who is also a radio host, and she's in the chat tonight. Carol Carl is the radio host for Behind the Obsidian Curtain Friday nights at 7 p.m. on kgraradio.com. And Amanda, Daryl, and I, we host the SkyTour Radio Astronomical Show on Sunday nights on kgraradio.com. And we're from 8 to 12 Eastern Time. She's 7 p.m. on Friday nights. And we're Sunday night. And our show from 8 to 10 goes over all kinds of astronomical events that are occurring. And we show people and tell people things that are kind of like what you have in a stream like this, except that it's on the radio, made for radio. But we do also do like KGRA DB, which is a television, and we do live broadcasting as well. And that's going to be more and more. We're going to be doing more and more of that. So we'll show things like, for instance, if I talk about comet orbits, for instance, I can talk about them. But isn't it much better if I just bring up something like this and talk about a cometary orbit, and let you watch what we're doing at the same time? I think that's kind of like the cool thing. So you can check all that out on kgraradio.com. And they have one of the biggest audiences. They have 3.5 million listeners, I believe. And for our show, SkyTour Radio, which is 8 to 10 on Sunday nights on KGRA, we're generally ranked between number 3 and 4 in our time slot, which is really amazing to see. So what it tells me is that people want to hear about the science. I do speculate about UFOs. I do speculate about extraterrestrial life. In fact, I wrote a book about extraterrestrial life and finding it. That's called The Populated Universe. You can find that on Amazon. And The Populated Universe is about finding the extraterrestrial nugget out there amid these new exoplanets that we've discovered. Because in astronomy, when I got a degree, it was in astronomy, and I took and focused on exoplanet technologies after the degree, and that's where I live. I live in the exoplanet world, and as well as being, a photo and video analyst for the Mutual UFO Network. Because sooner or later, someone's going to catch something that came probably from one of these exoplanets out there. I think that's a really cool, find waiting to be found. Remember, somebody once said, somewhere out there is an amazing thing waiting to be found. And I think that amazing thing is going to be life. In the book, I actually, at the beginning of every chapter, I put an interesting saying from a scientist, and that is sort of like the prelude to reading the rest of the chapter. So I think that's one of them, and I can't remember exactly what scientist that was. Here's another view. This is beautiful because now this is really showing the colors very well. Okay, you can see this beautiful color. You can see the tail of the comet, but you can also see this extended nucleus. Sad to say that it is breaking up. Breaking up is hard to do. Here's what I'll do. I'm going to go and I'm going to take the long way around here. I'm going to go to a white light shot here. I'm going to move the filter wheel. Let's do this. All right. Right now we're on the spectral wheel because I just changed it to that a moment ago. Then position 4, which you see here on the left of the screen right here, down here underneath the filter wheel, that's just a black disc that blocks light from going into the sensor. And we do that to create something called dark frames when we actually do many of them. And many shots. Now, this is 5. This is a straight through view, just a white light shot. And we have to refocus this because when you focus with the filters and without the filters, you do get a difference. So I'm going to just take the time to focus right now. We might as well do it. So I'm going to bring the star over that I wish to focus with. And then we will go from there. Here it comes. Hello, I'm coming over to play. Okay, good. All right, and that's the star we're going to focus with. And we'll bring it up a little bit. All right, and now let me just give it a little focus shot here. You'll see that it's going to get out of focus and somewhat distorted. There it goes. And I'm going to go back. Let me do it again.
Have you been keeping up with the questions while I was away?
I have not been able to look at the chat to read the questions, so I'm afraid that falls on probably one of the most amazing co-hosts I've ever had, who I should not have had because of how we met. It wasn't on the best of conditions, but it turned out that you were an amazing person, and I don't want to do SkyTour Radio without you.
Oh, thank you.
Yeah, Amanda. I thought he was going to blame me.
Daryl, I would never do that.
I know, and he said the best co-host he ever had. I'm like, oh, he's talking about Daryl.
Well, Daryl is by far one of the most enjoyable persons to have with us on the radio. Don't you agree?
I do.
Oh,
yeah.
Just wait till you see that Rule 34 picture I sent you, Mark.
You sent me one?
I did.
Uh-oh, is it in chat? The Skype chat here?
It's on your regular Skype.
Oh, okay.
Message. Don't.
I'm not going to do it now.
Oh, it's funny picture. I mean, and it's not lewd or anything. It's a picture from a Godzilla movie.
You know Daryl, he's not going to show you anything lewd. He's not like that. He's very nice.
I thought about sending it to you, Amanda, but you probably wouldn't enjoy it anyway.
Well, now I'm curious. Send it.
Oh, give me a minute here.
And while you're doing that,
while you do that.
yeah, while you're doing that, I want to just say, whoever had
I'm trying, guys. I'm
I
trying.
know. Whoever has the ID that begins with the word Archer, thank you for subscribing. I just got your subscription. So go ahead, Amanda.
Oh, I didn't see Archer's name in chat. They might be.
It might be a different ID.
Just watching.
Yeah.
Okay. It's okay.
So whoever has that,
okay.
thank you.
Hadley wanted to know, and this is probably going way back. He wants to know, what's the talk about this twice the size of Jupiter
Oh, look at
atmosphere
that.
comet? Oh, what?
I just
Talk about that?
sorry. We had a satellite go ripping through the field just now. Sorry.
Oh.
Go ahead.
Oh, okay. What's the talk about this twice the size of Jupiter atmosphere comet or asteroid that's supposedly arriving? I don't know this. Do you guys?
Would that be Comet Atlas? They were saying that the coma around the nucleus of Comet Atlas was like half the size of the sun.
Yeah, it was at one point, right? And that's apparent size, by the way, not actual size, right?
No, it was like on the order of 400,000 miles across, I believe.
Oh, that's right too. That's right. I'm thinking angular diameter, like the moon and so forth. Okay, yeah. But yeah, that's true. Here's a white light shot of the comet, and it shows the color better. And if we zoom in, you'll see that most of the pixels are this greenish color. Astronomers love zoomed images with pixels like this. You know, we don't see aliens in the pixels. That's for conspiracy people. You know, we actually just see the actual colors. Look at how extended that nucleus is. Very, very clearly a problem, you know, with this nucleus. Now I'm going to take this white light shot, and I'm going to go and drop down the ISO. Let's try 30 seconds at 1600. So we're literally just going for what might be hiding that might be brighter than that coma. Okay, so when we come back to our shot, let me just grab that shot here. We look at this shot, okay, if there's something in here that we're missing, it might be about the same brightness as this overall brightness. So if we reduce the amount of the exposure or the sensitivity, we might be able to pick it out. It might show itself. So let's see if it did. Okay, now I actually do see that we're seeing a bright area here and a bright area there. Do you see that, Daryl? Daryl's on mute.
Yeah.
So we have.
Sorry. Yes, I do.
See, we got that bright area there, and we got that bright area there, and maybe that third over there. So I think we're actually seeing that, and if I actually were to reduce the exposure even more, maybe I should do it by going like this. I'll go down to 20 seconds, but I'll increase this just a little. No, I'll just go 1 because so basically we've gone down by 1 stop. So it's going to be a little bit dimmer, but a little less grain because we knocked the noise down. So we're going to go do this at 20 seconds. The whole purpose is to see if we can see the fragments. So far, this last photo that I took, we can actually see some of the fragments in here. And we're going to do this. It'll be a little dimmer. All right, when it comes in, it'll be a little dimmer. Now I've got to just rotate it in. And that doesn't help. I would actually have to actually drop this down more and make this go up a little more. But I don't want to make you sit for 4, 5, 6 minutes at a time while I'm taking a single photo. The whole idea of SkyTour LiveStream is to show you things in seconds, not the many minutes that they would normally take. And I'm not going to normally take many minutes to take these things. Okay, Amanda, I'll turn it over to you now.
Okay, and this, again, it's going back a bit, so I'm not sure exactly what part of the conversation this was,
All
but
right.
Just in Time says, could the red artifact you spoke of possibly be a binary partner? I just asked because you said red and Atlas being blue. Could this place Hoppy blue and red Kachinas of Hopi legend? Sorry if I'm mispronouncing that.
No, that's interesting. In this case, I don't think so, and the reason is because the red dot didn't go out of focus when other parts of the picture did. When the camera moved a little bit, or wind got it, or whatever, we did not see the camera. We saw the camera go out of focus. We saw the scene go out of focus, but those red dots stayed very sharp. That's because they were artifacts that were generated at the camera sensor, not something that was at the comet, unfortunately. That's a clear way to differentiate.
Cool, thank you.
Let me just say, earlier, Daisy and Zoe, I sort of said hi to you in the chat, but I didn't say hi to you officially. So hello, Daisy and Zoe Amethyst. Thank you for being here as well. I like welcoming my friends who come out to see. Go ahead. I'm sorry, Amanda.
Okay. James Dugan wants to know, asks, can you put up a picture of the comet from a few days ago to compare the difference in the comet since then?
Well,
Great idea.
Yeah, it is. I can, but I would have to do some hunting. What I'm going to be doing is I'm going to create a montage and a GIF that shows it moving through the sky with all this. So we're going to be doing that. I take all the pictures from each night that I take pictures, and I store them on my Lacey RAID here, my RAID drive, and we will then take all the pictures and create a GIF file from their movement. I did that once already for some of the movement, and I put that out there, and I'll just tag onto that and make that next montage. Hey, DDB. DD's here with us.
Do that, and we have one last question.
Okay.
For the moment, keep them coming, guys. Oh no, we don't. Oh yes, we do. Hadley wants to know the AZ and direction. I'm assuming of the comet. I think that came up again when the satellite passed a little while ago.
Oh, okay, okay.
But I think this one was for the comet.
Okay, that was actually AZ is the azimuth and the altitude. So here, okay, if you look, all right, we're looking at this is northwest, that's north, all right. So this point right here, all right, this location, the azimuth is 327 degrees, and the altitude here is plus 40, just over 40, plus 41 or 42 degrees or so here. Okay, so the azimuth is 327, and the altitude is 41, 42 degrees. That's the azimuth and altitude of the comet. That's a very good question, because what's azimuth and altitude? Well, azimuth is, if you start at the north and you go all the way around, okay, it's 360 degrees, all right? So this is at 327 degrees, where we are right about there, okay?
Northwest or northwest.
Yeah, and then,
about the same height as Polaris.
Yeah, that's Polaris right there, and Polaris is at our latitude here, which is 41 degrees 33 minutes. So we do have that going for us. And that's the other thing, by the way. If we look at the altitude of Polaris, okay, let me see if I can see it in here. It's got to be here, right? Yeah, Polaris right here in this sky for this planetarium, it says it's 41 degrees, 11 minutes, 16 seconds. All right. Well, that's the altitude of Polaris. The exact latitude that I'm at right here is 41 degrees 33 minutes. So not quite the same, but that's because this was set differently. This planetarium was set differently. Okay, as far as looking up over your head. Well, what's interesting is when you look over your head, this is the zenith. Okay, when we look up here at stars at the zenith, all right. Well, that's zenith is 90 degrees over our head, right? But that's really, that's basically the spot, the zenith spot over your head is the spot that marks your latitude line in the sky. And that's kind of interesting. The stars of your latitude. I'm sorry, I'm doing 5 things at once, and I'm not focusing on points too well. I apologize. I've got my hands doing 3 different things. Daryl, I think you know what I was trying to say, right?
Yeah.
All right.
Well, let's see. I had to think about that.
Yeah, Polaris is at our latitude, okay? And that's the elevation of Polaris is the latitude. You can imagine at the equator, Polaris would be at 0 degrees, straight down the horizon, because you're at the halfway point. And we just had another thing go zipping through. Another satellite just went through. I wonder if we're actually now. Bill's probably screaming over in his site, right? Because he's looking for these satellites. I like looking at the live view. Live view's fun.
He was worried he was going to get clouded out.
Yeah.
I'm not sure. He might be. I mean, if the clouds held off, yeah, I'm sure he's going to be dying to see that.
Well,
I guess he got
we got these clouds here.
Shortchanged the other night. They were just approaching and clouds came in. I had just left, so that's what I heard.
Well, this is our latest all-sky shot. We just took 40 seconds ago. 40? Yeah, about 45 seconds ago. And you can see we do have clouds coming in. So this is in the direction of the south. Directly south is right here. All right. So the clouds are coming from this direction. So we can see that we're going to end up losing some of our view. Let me process this a little better, just to give you a better idea of what we're looking at. The Big Dipper's right here, but I want you to see it better. There. Now you can see the Big Dipper. Okay, and if we increase the black level a little bit, there you go. Now you can see that we have some clouds that are encroaching, and we're really we're trying to get a shot of the comet, and it's over here. It's right about there. So I would imagine that our next shot is probably not going to be very good, but we'll try it.
Are the clouds coming from the west?
They're coming from the west right now, yeah.
Yeah, Bill's probably already clouded out then.
Well, hey, I take every opportunity I can to stream so people can join and check it out, especially at this time when people don't have a whole lot to do with COVID going around,
Mm-hmm.
Yeah.
We have some more questions.
All right, go for it. And I'll hang out to answer questions if people want after the clouds long since kill our night.
Sure, sounds good. D. Vincent wants to know, depending on where you are when it passes, will this comets be visible to the eye?
Some comets will be. This one probably won't. Atlas Y4 is probably going to continue to get dimmer.
But if it had stayed intact, it would have been visible in the daytime sky, right?
Possibly.
Yeah. Okay. See, this is exactly what happens when we see clouds in the white light shot. Okay. Well, tonight, as I said, I mentioned that the comet, clouds would probably wipe out our view of the comet. And okay, there's the North Star. There are the 2 end stars in the bowl. You go to there. You go over there. And we're kind of in this mess right now. So yeah, we have clouds coming in, folks. But that's why the all-sky camera, Remember, I used to have to get up and say, "Oh, let me go check the weather. Let me go see if it's still clear out." Well, now I just have this beast, which gives me an all-sky view. This will be implemented out in Arizona at SkyTour LiveStream West. We're still on schedule to go out there at the end of June and build the building. And maybe once the building is built, we'll be able to get the posts installed and rails that the garage door people can then install the rails on, and then have the roof attached to those rails, and then motorize it with a regular garage door opener. And we will be able to remotely, just like I run the scope from here, I will also be able to control what goes on in the observatory. I've already written the programs to do it and worked out the way to make relays go off to open things like a garage door, which is going to be a horizontal flat, or it's a horizontal roof, basically. And that's going to be pretty good, and that'll work very well. So that'll be end of June when we're going to start that process. I had wanted the observatory to be online, as I told you guys earlier. I wanted it online at the end of this month, but unfortunately, the COVID problem caused me to end up not being able to do that. I had to, I had to sit back and just wait and let it happen, let it go through the course. So I canceled the plans to go out in April, and I bought a changeable ticket for the end of June. So if anything happens, I say I bought. I didn't buy the ticket. All right. The Observatory Fund bought the ticket. Yeah, and Marianne says it. And Marianne is extremely important to all of what goes on with SkyTour LiveStream West. She's actually literally, don't ever get on her bad side. I mean, I haven't been. I mean, she's a police officer, and she could tase me, but and she threatens to once in a while. But I think that Marianne is critical, because she does a lot of things to help take care of things that need to get done out there. She visits places. When we were talking about the building for the observatory, she visited these places that make these different buildings, met the owners. I mean, she went and did all this legwork that I would have had to do. So I am eternally grateful to Marianne. So thank you, Marianne, who is in the chat now, which is great. Thank you. D. Vincent, thank you for coming by. I'm glad you could stop by. And Daryl,
we have another question.
Okay, go ahead.
Before you run away.
Yeah. No.
Eugene wants to know, and I like this question. Could NASA place an instrument package time capsule on the nucleus of Y4 to monitor the comet on its trip through space? I think we probably would have had to start planning a long time ago, but that's a great idea. Why didn't we?
Yeah, that's absolutely true. I mean, let me tell you something, though. That would have been interesting. I mean, the Rosetta mission.
Philae.
Yeah, exactly right. Rosetta mission, you got it. The Philae lander from the Rosetta mission, and that the Rosetta spacecraft was orbiting Comet Churyumov-Gerasimenko, which is 67P, P meaning periodic, and the comet looked so different from what people think comets look like. It was astonishing how it looked. And the surface of comets, which is hard to believe, is almost black. But you see them as gray in the photos because the camera's has to expose for a lot longer to get a shot. And when it does, they come out gray. It's all tones of gray, but it's really almost black. So comets are really notoriously hard. But the thing that's important is the comets outgas, and they give off all this stuff that can then be excited by the sunlight, and you can get this glow, which is caused by carbon atoms. Cyanogen makes this green glow around the comet nucleus here, and carbon monoxide, and double carbon, a carbon molecule, with two carbons. Carbon, it's called C2. So that green that we see then, that's something that is, comes from the high energy sunlight interaction. But we're not seeing the color of the comet. The color of the comet is nothing like that. The comets are generally very dark, and it has to do with how long they've been in space, the kind of material that was deposited on their surface, the kind of radiation that hits their surface. So it's really fascinating that we can see these at all. So I really love these comets. They're just beautiful. And if you ever wonder what would happen if we got hit by a comet, you only have to go back, most likely, to the Tunguska event. So if you look that up, Tunguska, Tunguska, Tunguska event. That happened in, was it 1916, 18? No, was it 14? I forget. Daryl, do you remember the date for Tunguska?
Oh, God, you would ask me that. Yeah, somewhere in there.
Yeah, okay.
Somewhere in 1914 to
early 1900s.
1910, 1918,
Yeah.
something in that time frame.
And it's believed that a cometary fragment actually hit the Earth. Now, it could have been from one of such things like a comet fragmented, but it was already on a collision course with the Earth. And maybe one of those fragments dissipated, or maybe the entire comet struck the Earth. And what we found is, thank you, Terry Groff, 1916. See, you can always depend on those guys, And so when you look at things like that, you look at the Tunguska event. I think that it's important that you consider the kind of energy that's being liberated when you have such an event happen. When a comet strikes the Earth, it's hitting the Earth at really thousands of miles an hour. Okay, so it's going many miles per second. Okay, and it hits the atmosphere, and when it's going that fast, it can literally get through the atmosphere in a very short amount of time to get to the ground, so to speak. But the atmosphere fights back. The atmosphere pushes back. Okay, it might be 1908, Terry, I think, but that's okay. Oh yeah, look, there it is. Carol put it in 1908. Sorry, thank you. I made you a moderator, Terry.
Yeah, it took him years to get there after it happened.
Yeah, because it was so isolated, and what they found was a blast radius that went out in all directions radially from a central point. All the trees, I mean, massive old growth forest, knocked down. Think Mount St. Helens during the volcanic eruption when that pyroclastic flow came out of that caldera, that crater of Mount St. Helens. It leveled forests for miles in several directions. Okay, that is what Tunguska did radially in all directions for many miles. And this was an airburst. That is to say, the comet exploded way up high. So, and when it did explode...
I see something in chat that's kind of throwing me. Laura's saying, will Mark be able to grab a picture of that big asteroid tonight? We're looking at the asteroid. Does she mean...
I mean the comet.
Asteroid?
No.
Okay, that was throwing me. Oh, she's talking about... Okay, never mind.
Yeah, now, okay. Laura, let me show you what we're dealing with right now. I'm going to just head back to our other view for 1 second, just to give you an idea, because sadly, if you look at our evening sky tonight, we're being clouded out. I'm sorry. I wanted to squeeze out a stream if I could, and we were able to do it. But eventually we'll take pictures of asteroids. I think that we can. And Carol's throwing some really valuable stuff in just to give you an idea of how the Tunguska event affected people. But 40 miles from the scene, a farmer who was out working in his field had his shirt burned off his back by the impact of the comet in the upper atmosphere. The shockwave and thermal energy that got to the ground actually burned his shirt. and his clothing. Now that's a lot of energy, and that's what happens with these types of events. Now, you might remember 2012 Chelyabinsk. The Chelyabinsk meteorite struck, and when that meteorite struck the Earth, it was seen all throughout Russia. It's caught on dash cams, caught on security cameras. Looks like a second sun in the sky for a period of time, leaving these really stark shadows as it moves across the sky in some really unearthly manner. And then, of course, when it blew up, the airburst and concussive explosion blew out windows. I saw it on you can go watch this video online, look it up. A security door, a steel security door at a facility was bent into a V from the shockwave hitting it and blown open. I mean, people in offices, suddenly the big windows in their office are just blown right out, as if not even there, and everything on their desk is like ripped off, and they're huddling behind their desks, injured from flying glass. I mean, this is what happens. This was.
Don't forget that article we talked about recently. The village in Syria 11,000 years ago that evidently got hit by a comet.
Yeah, we actually talked about that on SkyTour Radio. Yep. That's right.
It incinerated everybody and everything in the village.
Yeah, and that's part of the history too. I mean, and of course, you always get there's always some kind of mythology that grows around these kinds of events. But we do think that it could have been a comet striking in what is now Syria, and it's actually at the bottom of a lake now, the entire ruins of this town. But they knew that the entire town was obliterated because when they examined the ruins, they found this molten glass material on the walls of the buildings. And the only way that could have happened is with a very, very high temperature and from a blast, a shock impact. So it appears that this town was wiped off the face of the earth by a cometary impact. And that's right now, I think that's really the only extraterrestrial event that killed humans that's occurred here on Earth. No, I don't consider dinosaurs humans. But that's the only extraterrestrial event that killed humans is that cometary impact.
They said the temperature would have melted a car in a couple of minutes, and being a flash event like that, it probably incinerated the people and the livestock instantly.
Yeah, it was about like 4,000 degrees Fahrenheit, which is what, 2,700 C? I mean, we're talking, 2,400 C. We're talking a very, very high temperature. Hadley, he says, "Oh wow, I don't feel safe anymore." Well, yeah, but keep in mind that we do have what's called the Sentry program, and every object that's found is added to the Sentry list until its orbital elements can be determined, and thus most of the elements when they're found determine that the object poses no danger to us long term, and they project into the future very, very far. So clearly this can be a problem, and clearly we can be a target. And I'm going to say one more time. All right, one more time. Our moon does not help us. The presence of the moon does not make and did not make life possible, in my view, and I can tell you why. First of all, people say, well, without the moon, we wouldn't have tides. And that's wrong. Without the moon, we would. But the tides would be half the height. And that is because the tides would be coming from the sun. The sun generates tides as well. And they're about half the strength of the moon's tides, actually. So we would still have tidal pools. We would still have times when fish and water-breathing creatures would be left alone to to be parched in the mud flats for a while. So the mutation to create lungs and air-breathing systems would still have been enforced. It would have probably taken longer, though. So even so, if we had no moon, there would be some differences to the way the Earth developed. We wouldn't have a day that's 24 hours long. Our day would actually be a lot shorter because the Earth rotated a lot faster earlier when it was formed, and there was no reason why it would have slowed down. But the reason it slowed down is because of the moon's interaction with the Earth. So our day would have been a lot shorter. Probably would have averaged out to about 18-hour day. Which is kind of cool. I could go for that. But all our telescopes wouldn't work because they would be, they're following at what's called the sidereal rate or star time. They're rotating at exactly the speed at which the stars move relative to the rotation rate of the Earth, and they wouldn't work. So we'd have to change those all around, wouldn't we? Well, we would have just designed them to work right to begin with, and we would be moving at way more than 1,000 miles an hour at the equator that we're moving now. And let's hope the Earth doesn't just stop dead, because if it did, we would just all slam against the wall really hard.
Mark, excuse me, please.
Sure, Daryl.
I need to go. I'm sorry. I am fading really fast here, okay? Will you excuse me for the night?
Sure, Daryl. Thank you for
Okay.
coming by.
Daryl.
Yeah, thanks for having me on. Y'all take care and have fun. Have a good night.
All right, Daryl.
Talk
Thank you.
soon.
We'll see you later.
All righty, bye-bye.
And let's hear it for Daryl Mason. Yay! Yeah. So Daryl's been fighting sickness the entire winter, unfortunately. It just, whenever he was getting better, something else would strike him, And so it's like, I give him so much credit for, hanging out with us as long as he's been able to with all this going on. But anyway, he's a good guy. Any more questions there?
I don't think so at the moment. No, the last one was from Eugene.
Okay.
No, we're all caught up. I mean, if people want to still throw them out, go right ahead.
Okay.
People are just talking about material left from the Tuscany asteroid.
Tunguska? Or
Charles was saying part was found put in a dagger and some jewelry and stuff, and interesting.
Yeah, but Tunguska. See, here's the thing: Tunguska could have been a comet. Tunguska could have been a small asteroid. But the thing is, nothing made it to the ground of any substantial amount to determine what exactly it was. So we didn't get enough. Now there may have been some material recovered, but I'm not sure how much there was at all. So. But it's interesting, though. I mean, I'm sure Charles is right, but because Charles never makes comments offhand without having researched them first. That's what I really like about Charles. So let's see. Okay. Okay, Bara says...
Oh, I was just about to say, we got another question.
Okay, go ahead then.
Locating the position?
Yeah, go ahead. Go for it.
Yeah.
You can read it.
He just wants to know, can you teach us how to locate a comet position in the sky? Great question. Yeah, we should have done that first off, I guess.
Yeah. Actually, I think that the first thing that's basically a small mini course in astronomy, Bar, and I think that maybe what we'll do some of that at some point. I know that when we go and look at screens like this, they can literally be very confusing if you don't know exactly what you're looking at. But when we look at this, we're looking at our solar system here. We see the sun, we see Mercury, Venus, and the Earth is the blue. Okay, we have Mars, red, and then we have Jupiter way out here. Well, the asteroid belt, for instance, is in between, right? And how to find a comet in the sky? Well, if I zoom way out, look at these crazy orbits. for these particular comets that we've been looking at, these 3 comets in particular that are currently being focused on here, these orbits are pretty wild, aren't they? So basically what we need is something called orbital elements, and those are just little numbers that tell us things about the amount of ellipticity, how elongated the orbit is, and whether it's circular or elongated, the speed at which it might be moving, and its closest approach to the sun, the elevation above or below the solar system plane, which is right here, and so forth. And each of those parameters overall will build a full picture of the motion of the object. And so, like I said, whenever they reach and find a new object, it's put in this Sentry list, which then, as they develop the orbit of the object, will either be removed or given a big red flag, and we'll all have to move to the moon or something. Well, the bottom line is that to go through learning astronomical coordinate systems, that's a whole course in itself, and maybe we will focus on that for a night, and I can go through that. If people want that, I'd be happy to go through and show you how that all happens, how that all works. So I think that yeah, I mean, because right now I wouldn't be able to explain it adequately right now, because there's a lot of background that we need to go through, like how we determine where things are in the sky at all. How do we do that? Well, that's our latitude and longitude lines spread out into space, extended out into space, and we change our latitude to something called declination, and we change our longitude lines, which are the long lines that go from North Pole to South Pole, to right ascension hours. And there's 24 hours in a day, so we have 24 hours in the right ascension sphere. And then, so the comet will be at a certain, and there's different, when we talk about the hours in the day, you might think, well, wait, doesn't the right ascension and declination, don't those numbers change all the time because Earth's rotating? The Earth's rotating, but the hours stay the same when you're talking about space. So the comet will always be, for tonight, it'll always be at 6 hours and some odd minutes of hours in the 360 degrees of 360 24-hour circle. Boy, that's coming out bad. It doesn't even sound good. I need diagrams. That's what I got to show you guys. And for the elevation angles, well, for tonight, the elevation angle will always be the same, for the most part. Okay, so I'd have to give you guys a little mini course in how we look at things in the sky and how we actually figure out where they are, and how we can then predict where they're going to be. And that's where these orbital elements come into play. And I'm going to do that for you guys at some point. So if you're really hardy and you want to sit through it, I'll be happy to do it. So I'll turn it over to you, Amanda, because I saw the screen get pink over there in Skype, and I think that's I think that's something that meant you had a question coming through.
Yes, actually, I have a second one. Let me just throw that in there before I get lost. And I'm so disappointed. Anonymous asked, hold on, let me scroll back to the first one. Anonymous asked, how long is the orbital period of Comet Atlas and how many years? And I was going to say, I thought it was 6,000. I thought it was something like 6,086 or some weird number like that. But Charles just beat me to the punch and said 6,016.
That's correct, yeah.
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 It's not very often that I can take a stab at questions. So
no,
that's okay.
You know what? In the beginning, your guesses were not educated guesses, but they were just guesses. But now they're educated guesses, and guess what? A lot of them are correct. So that's the thing. If I come very close. Clue,
I try to draw on little bits and pieces of things that I have heard in the past.
Yeah.
And they might not make sense, and they might not be, I'm not shouldn't be applying it to what we're talking about, but it's like a term that applies somehow, But
Yeah.
yeah. But I remember hearing that it took, because I asked that actually, how long the orbital cycle was, and I remember someone said it was a little over 6,000 years. So
Yeah.
but I mean, if it disintegrates, it won't make another orbit, will it? Or will those little pieces keep orbiting, or will they be long gone before they come back in 6,000 years?
And that goes to Anonymous's question number 2.
Second question, yeah.
Which is, if the comet Atlas Y4 disintegrated exactly at this cycle, is this the last orbit of Y4? Yeah. As a cohesive comet, it is. And so we're actually watching, I think, the death of a comet. We're actually seeing the death of a comet. When we look at this view right here, we're watching and looking at a comet that is an X-comet. It's on its way to becoming just a collection of icy particles, and it's not even at the sun yet. If it was on the other side of the sun and coming out, I'd say it has half a chance. But it's already breaking up before it even gets to the sun. And that means a lot more surface area of these cometary fragments are exposed to the blistering radiation of the sun as it goes around. So I'm guessing that some of those pieces will be completely evaporated by the time they get around the sun. Maybe there'll be some small piece left, maybe, but probably the largest that's left behind. Amazing, though, huh?
Do you think if we do see any of the pieces, even just one, come back around the sun, do you think we'll see it totally disintegrate before we lose visual contact with it? Before it, I don't want to say leaves our orbit, because that's not right, but you know what I mean? Before it gets too far out that we can't see it?
Well, the thing is, as it's leaving the sun, if we see it, it's because the sun is having an effect with its ultraviolet radiation, and so we'll see it. So if on the way out, if the comet is finally on its last legs, and if it turns out that if it turns out that as the comet leaves, if the sun's final parting radiation is enough to break up that final small piece, then yeah, that'll be the end of it. And you got to remember, when a comet goes around the sun, it's leaving dust in its wake, right? Dust and debris. And we're not seeing dust and debris every time we look at a comet. Like right now, this green, we're looking at atoms of carbon that have been ionized. And then when those electrons recombine with the carbon atom, they go to a specific location within the atom called an energy level. And when they do that, they gain energy to be ionized, and then they give off energy when they go back into the atom. And when they go back into the atom, they give off light. And that light is this characteristically green color we see here. Okay? That's why nebulae light up the way they do. All right? Comets light up the way they do. However, also with the ultraviolet radiation-induced effects that we see here, there's also a dust trail left behind the comet through its orbit. Dust that comes off the comet, blown back by the solar wind, never to find the comet again. It's now lost in space, and it's along the orbit of that comet. So when it's sitting there along the orbit of the comet, if the Earth happened to pass through it, which in this case we can't because it's too far above and too far below our orbit, we would actually see those particles coming into the Earth's atmosphere and cause a meteor shower. All meteor showers come from the tails of comets as we pass through those dust tails. Think of comets as, in the Peanuts cartoon, Pigpen. Whenever Pigpen's walking along, you actually see this pile of dust behind him as he walks along. Well, that's what comets are. When they get near the sun, they become Pigpens. And when they get far away, well, then they freeze up again and they become what we'll call inert. They don't do anything. So I think that's interesting to understand. You should know how that part of it works, so you know what to expect with a comet. So is there any more questions, Amanda?
Lots more coming in, actually.
Okay.
I'm trying to keep them in order. There's one I'm excited about, actually. I think it's a really good question, and I'm sitting back thinking about it. I'm like, I bet there's a few people in chat that actually do know this answer, but I don't know if I've ever really considered it, so I'm excited to hear the answer. But
All right.
we're going in order, so let me get back here. I like this one too, actually. Charles asks, what's the result of the death of a comet? Is it a meteor shower?
Only if we pass through the tail at some point. But the result of the death of a comet is that the material evaporates in space, and whatever particles are left behind will just continue on that trajectory and that orbit till the end of time, I guess, right? Because they will, wait 6,016 years, if in this case for this comet, and then when they come back around the sun, well, maybe the sun will have its final way with them and vaporize the remaining particles of ice. And then that'll be that. But the dust will remain in that elliptical orbit. And don't forget that this elliptical orbit, the dust doesn't start accumulating till the sun starts working on this nucleus. That's when it leaves a trail of dust. It's inert when it's way, way out there. So when we're looking out here, okay, let me show you this. When we're looking way out in the far reaches here, like way out here, when we're out here, okay, in this orbit, and then this orbit extends a huge amount, just incidentally, just so you can see. Okay, but let's go in here. Okay, we don't start seeing the comet until it reaches somewhere around here. Right around here is when we'll actually start to see the comet tail, somewhere just past Mars, where it's near the asteroid belt a little bit. Then the sun may be able to start causing the coma to occur, that brightening around the nucleus of the comet as chemical and radiative reactions take place when the ultraviolet radiation from the sun strikes it and causes this stuff to come off the comet's surface. The comet starts to heat up inside, and trapped pockets of gas will explode through the ices on the surface, causing these gas jets to come out, just like we saw with Comet 67P with the Rosetta mission. And then the comet gets brighter and brighter as more material is blown off of it, as it moves. So the comet is, as it comes closer to the solar encounter, to the sun, it's going to then start growing a tail. But the tail is going to be, there's one tail that always points away from the sun. So that tail is called the ion tail. All right. And so when we look at this, if we look at the comet, now these comets are not shown, and they're just, that's the symbol for a comet. It's not, astronomically accurate. But if we look at what happens when the comet comes close to the sun, all right, let's pick an orbit here. Let's pick Y4, okay? So here's Y4. As it comes close to the sun, it swings around, it goes way back out, and that's extremely foreshortened. This far end of the curve goes a long, long way past Pluto. But as Y4 comes down, a tail starts forming that's pointing directly away from the sun, based on the ultraviolet energy from the sun hitting the comet and driving off atoms from the surface of the comet nucleus, and they end up interacting electrically with the solar wind, which is charged particles, and they end up pointing directly away from the sun. And because they're interacting electrically, and because of the nature of how this works, they're blue. And early on, when Comet Atlas was out here, not just as it had passed the orbit of Mars, we were able to see the blue ion tail from Comet Atlas. We saw the blue ion tail very clearly. And when we saw the blue ion tail, that was followed up by another feathery kind of tail that we were able to see of the dust that was being left behind. Then as it comes closer, what we would have seen if it stayed cohesive was that ion tail would have started to separate and angle away from the dust tail. The dust tail is going to be following this line. And when it's far away, the ion tail would follow this line a little bit. But then as it gets closer to the sun, and in particular when it gets past the sun, the ion tail is going to point out here. It's going to point away from the comet. But the dust tail is going to go this way. It's going to be in this trajectory. And then as it comes around the sun, the ion tail is going to swing from this direction to this direction to this direction. And then when it finally gets out here, it's going to be pointing in this direction. And as it points in this direction, when it gets out here, the ion tail is going to be pointing away from the sun, and the comet's going to be racing into its own ion tail. Yet it's going to be leaving dust behind it all along the path. So dust tail, ion tail, that's the world of comets. And so they're very strange. And so when you look at a comet, you can sometimes see the ion tail and then a dust tail, and they'll look like two separate tails. And we've seen two separate tails with Comet Atlas Y4 in previous nights. But now we're losing definition in the comet, unfortunately. So we're not able to see it anymore. That may or may not change. It depends what happens in the nucleus. But we'll see, We'll see. So hopefully that kind of explains, how the comet actually operates. Amanda, is there more question? Go ahead.
There's a bit of a debate happening in chat. Anonymous said, I thought the tail of a comet always pointed towards the sun. And Charles said, actually, they always point away from the sun.
That's correct.
And a monorail says, not true, because Y1 is evidence that tails have their own path. So can you clarify what's actually going on and why it is the way that it is, however it is?
Yeah, everything I just said is actual. When a comet is coming toward the sun and the solar wind strikes the comet and starts interacting with it electrically, it will send a lot of those ions that it creates backwards away from the direction of the sun. So no matter which way the comet's going, the tail of the ion tail, from a comet will always face away from the sun, because that's the direction that the ultraviolet energy is coming. All right.
Always.
Yeah.
So
it'll always face away
from
the sun. No, the comets are all the same when it comes to that, and you're not going to find an ion tail pointing in any other direction than away from the sun, and the dust tail will never point in any direction other than along the route that it was traveling. Just like Pigpen walking down the road, he leaves dust behind him everywhere he goes. Well, that's what the comets do. They leave dust behind them all along their path as soon as they become active near the sun. But the ion tail always points away from the sun. So as the dust tail keeps depositing stuff all along the path of the comet as it moves through its orbit, the ion tail is flipping and turning away from the sun no matter where it is. So when it's here, it's pointing this way, okay? But the dust tail is going that way, The ion tail is pointing this way. So in this particular case, what I was showing you. So when we look at a comet orbit, let's do this. So we look at this comet orbit here, okay? Here's a comet orbit we're looking at right there, okay? Right here, the ion tail is going to be pointing away, but the dust tail is going to be behind it this way, but the ion tail will be over there. So from the Earth, we might actually see a dust tail to the right, and then an ion tail pointing away, totally separate. And the ion tail is going to be blue, and the dust tail is going to be the color of the dust left behind. So generally, we'll see it being illuminated by the sun.
Okay, and kind of a follow-up. There are other questions, and I'm going to go back to it, but just while we're on this subject. If the comet's ionic tails are pointing all the time from the sun, is there a day when the tail of Y4 will be pointing exactly at our planet? Interesting.
Let's take a look. The answer is... The answer will be no, okay? And here's why. This is Y4's orbit right here, okay? Okay, now Earth is here, all right? Y4 is not going to go around the sun while we're over here in our orbit. All right. If we were over here in our orbit and Y4 went around the sun there, then its ion tail could point right at us, yes. But it's not, because we're not there. Okay, we're actually, this is relatively accurate in a big picture. So we're here looking at Y4, okay? And this again is, where's Y4? Where'd it go? Oh, right here. So this is Y4. Let me just separate these out. Okay. So you see Y4 right there. Okay. That's, this is Y4's orbit right here. Okay. It's not, where Earth is, we're never going to have the tail pointing at us. It's always going to be pointing away. But if Earth was over here in its orbit at the time that it went around the sun, then it would be pointing right at us, but we'd never know it because it would actually be pointing at us directly from where the sun is located, so we would never see it. So if an ion tail is pointing directly at the Earth, it's going to be during our daytime. So we would never notice it. We'd never see it. Sensible?
Yeah, no, makes sense. No, I mean, it was just, I just, and that's what I like about the community. I say it all the time, like, people throw in comments or questions, and it just gives you a different way of looking at things. Like,
yeah, we got great people here.
Like, I never really considered that, and then it's like, ooh, is that possible? And what would happen if it did happen? And, yeah. Interesting.
Yeah, we've
anyway,
got
keep them coming, guys.
We got great people here, man.
A few more.
Yeah, go for it.
Hold on, let me. Terry wanted to know what software we were looking at right now.
This you can go look at right this moment, Terry. You can check it out. It's actually on the skylive.com, and I just selected. I selected
that,
the,
and then it's like, ooh,
I selected
possible, and
the,
what would happen if it did happen? And...
Yeah, there we go. I selected the. Can you hear me?
Yeah, but you seem to be breaking up a little bit.
Yeah, that was weird. Okay, sorry. I had an issue that I had to fix.
Yeah. You're good now?
I think so. I think I am. Hold on. Yes. Okay, I'm all set. Now I'm going to get back here. All right, yeah. So, going back then, the skylive.com is the one that shows this image, and it's when you pick when you go there, it shows you the most searched for objects, and you'll see right now Comet Atlas will be in boldface, in the middle of the list of objects. So you pick it, and it'll take you to a Comet Atlas page, and then you can actually go and check out this drawing and this view. I've taken this, I've pulled it out of the view that's in, and I've kind of isolated it just for us to see here. Okay, because I've added it to like our little broadcast system here, so we can, make it something that looks really nice for you to see. So there's the comet right there that we see, and then of course I have this guy just sitting over there. I can just jump to with a nice little fade and transition and go show you in a way that's entertaining as well as classy, and I kind of like that, So, but yes, skylive.com is where you can find that. Terry Groff, if you were asking, that's where you go. And for anyone who wants to know.
And next up, Trish, and this is the one I like. I have a guess, but something tells me I'm going to be off. Trish wants to know, how small does it have to be for it not to be considered a comet anymore?
And I'm waiting for your guess.
Wait, I think I read it wrong originally. I don't have this. I thought you meant, once a comet is so small, what would it be called? Would it be an asteroid? No.
No.
That's why I thought it was wrong, because I figure I don't think asteroids come from comets. I think they're two different things.
They are.
Yeah.
However, okay, let me answer the first part. How small does it have to be? There is no...
to be not considered a comet anymore, yeah.
Yeah, there is no minimum size, but there seems to be a certain minimum size of survivability. Below a certain size, a comet might not be able to withstand the ultraviolet radiation of the sun. Remember, look how close look how close that this particular comet is actually going. For instance, Y4, it's going to be inside the orbit of Mercury. It's probably not going to survive that plunge. Okay, but then look at Comet Y1 Atlas. Look at its orbit. It's going to pass right here. It's going to pass sort of like near Earth, right, when it goes this way. Okay, that's actually already did, I think. And maybe its tail will be wide enough that we might actually see a meteor shower from it, because you can see how close it got to the Earth there. But and Christensen, okay, Comet Christensen is more shallow, so we are gonna possibly see something from Comet Christensen. But there's no minimum size, okay? There is a minimum survivable size, though, I believe, and I don't know what that minimum is. That's probably in the journals, and it depends on what the comet's made of and so forth, its density and so forth. How much rock particles are mixed in with the ices and stuff. But bottom line is that these comets, they do have a lifespan, and every time they pass by the sun, they're evaporated a little bit more. And it's not like they go out to the Kuiper Belt way out here and get more stuff. Okay. There's an off chance they could collide with something and maybe pull in some more dust along the way, but in all likelihood they're going to just disintegrate on their next visit into the inner solar system.
What would the maximum size of a comet be? Is there one?
I don't think there's a maximal size either, but the fact of the matter is that the Kuiper Belt you could actually consider that many of the objects out in the Kuiper Belt and the Oort Belt and then Oort cloud beyond are going to be icy predominantly, full of things we call volatiles, as in volatile. It's something that can easily be evaporated away by solar energy. The inner solar system has rocky planets in it, okay, because the volatile planets, the ones that are mostly like gas giants, would be evaporating away slowly. And in fact, we see that with exoplanets when there's like Jupiter-like planets that are right near their sun. They're usually evaporating away unless they have a specific type of atmosphere that they're not very puffy. I mean, so comets are made of volatiles. So we see this volatility when they go around the sun because the melting takes place, and that melting is something that you just can't miss, and it really shows up very well. So
what was the biggest comet we ever saw? Tunguska?
Tunguska? No, that's actually a small comet. If it was bigger, then it would have spelled disaster for a great many people.
It did so much damage, I figured.
Yeah, it did damage. But I don't know the biggest comet. We would have to guess on the sizes of some of the nuclei of these comets. But they're always bigger last time around than this time around. They don't get bigger when they come back. They're smaller and smaller and smaller if they are periodic comets until finally they're gone. They're transient. They're not a forever object if they're periodic comets.
Just a theory being thrown out here. Daniel says, so if Pluto decided to take a quick left and tour the inner solar system, it would be a comet?
No, it'd be a dwarf planet. Pluto has volatiles, but it's also got a rocky core. Pluto should be a planet, as far as I'm concerned. But Pluto would actually end up being like it's a dwarf planet with volatiles covering its surface. In other words, the materials that we'd find in comets, we would find in potentially on the surface of Pluto and underneath its surface. So.
Okay. Let's see. Anonymous wanting to know, can you somehow turn on electromagnetic filter on your telescope?
I'm sort of doing that. I'm going between three different filter types on the telescope using this filter wheel. Terry, I know what you're saying. It's not skylive.com. It's theskylive.com. Theskylive.com. Now you'll get it. So I mean, I'm looking through three different types of glass on the filter wheel when I'm in the telescope right now. I've shown you. I'm trying to show where this is. This is what it looks like when you go to that page, Terry, the Sky Live. You actually see the most often searched thing here. Okay, and you can see all the others. All right, and then we actually focused on this guy right here. I thought that this would be nice to bring in this view and bring it up for everybody to just enjoy, so we can check it out. Now, as far as our commentary view, this is the view that we last were able to get, and unfortunately, as you can see, our sky has been somewhat clouded out, and I really don't like that. I'm sorry about that, but I'm not in control of the sky, guys. What can I say?
Not yet.
Yeah, right. I tried. And so we do see stars up there, but again, we're looking with a very sensitive all-sky camera right now. If you look at this outside, you wouldn't see these clouds with your eyes. They would actually be very, very hard to see, because it looks like almost daytime in this shot, and it's a low-light camera that I'm using. Ah, yes. But hey, we had a good time, didn't we?
I think so. Hope everyone in chat enjoyed.
Oh, I really loved all your questions, guys. You guys are just amazing. Do we have more questions?
There's one more, but I'm not really sure how to read this.
Okay.
Because they're using a whole bunch of dashes, so I don't know. Can you check the side chat in Skype, please? It's the last, other side, no, in the group chat.
Oh, duh. Where was I? Isn't I?
Your Skype looks weird.
It does, doesn't it?
Go the top one.
This one,
Ongoing
right?
call. Yeah.
That's where I was.
No, in the little, yeah.
Okay, that guy.
The one on the very last one.
Okay. Oh, down here?
Yeah.
Okay.
Do you see how it's written? So there will be an Earth dash iconic tail of Y4 dash Y4 dash to the sun. I'm not sure if that's like trying to draw like the lineup.
Yeah, let me read it. Let me read it here and see what we got.
I think he's writing it like as if it's an alignment.
Yeah, okay.
But I just want you to see it so you can understand it.
Yeah.
It's your last question, Anonymous. We're working on it.
In looking at it, well, okay, he's trying to say, will there be a date when this particular alignment between the comet and the Earth and the Sun will occur? So Earth, ionic tail, Y4, Sun, straight line during the daytime. Okay. Not with Y4. The ion tail will never be pointing toward us. Anonymous. Or anon. It'll never be pointing toward us, but I know what you're trying to get at here. If we were, in fact, let's go back to the diagram that'll help you with this. If this particular comet was, if this particular comet was coming through, and again, this is Y4's orbit right here. Okay, right there, going through, zing, right? Well, if it was coming through when Earth was not here, but say here in its orbit, all the way down at this end of its orbit. If we were here at that point, then the comet would come around, and as it went around the sun, we'd have the sun, the comet, its ion tail, and then the Earth. That alignment could be, if we ever had that happen, we could have that. All right, but it would go in front of the sun, as seen from Earth potentially. But as you can see, Earth is here, and we're not going to ever get that tail pointing toward us because it's not going to go between us and the sun ever. Follow? So hopefully that makes sense.
It does. It does to me.
Yeah.
That's it for questions.
Okay, well, Bara had another one here.
It was for chat.
Oh, okay.
Well, I mean, hey, you're in chat.
What type
Have
of
you heard
historical,
any kind of
religious
historical or
information?
religious information about the 2020 comet? But give some, sources.
Okay, I see what Bara's asking.
I mean, you know more about the comet than I do. Are there any, theories out there? A lot of things in the sky have kind of.
Yeah, but usually.
Lore.
Yeah, but usually the things that really spark the most excitement are the things that everybody can see in the sky. This can't be seen. This is too faint. We're kind of peeking behind the curtain a little bit. We're not cheating, but we actually find. I gotta do this for Terry.
I got it.
Oh, you did it? Okay, thank you.
The Sky Live.
That's right. Yeah.
Yeah,
Thank you very much.
And it worked for me, so yeah.
All right. Yeah, so when people see something in the sky, that's when it sparks, the theories and the talk. For instance, when there's a volcanic eruption halfway around the world in the early days, there were extremely red sunsets and sunrises, and then when other volcanic eruptions occurred, there were times when there was no daytime. It was like nighttime, and this sparked fears and panics all over the place for in ancient peoples because they didn't know what was going on. So it's something that has to be seen typically in the sky. Right now, I've heard nothing about Y4. I know that when Halley's Comet was coming back in 1910, this is what we talked about before, Bara. Camille Flammarion, French astronomer, the Carl Sagan of his day, he said that because the comet has, and people could see this, because the comet had this bluish haze, this greenish blue haze that you see there in the picture, because the comet had that, and because they identified it as cyanogen, which is a cyanide, compound, right? Because they defined it or saw it as cyanogen, Camille Flammarion said, "Hey, if Halley's Comet hit, his tail, if we go through the tail of the comet, then Earth is going to be bathed in this cyanogen, and it could kill lots of people." So Halley's Comet, of course, was spectacular in its 1910 appearance. So people were, because they could see it, they were panicked, all right? But Y4, you know what? You ask anybody on the street, you say, "Hey, have you heard of Atlas Y4?" And they'll say, "Is that a car? What's that? An Atlas Y4?" As you can see. So it really isn't sparking anything right now, Bara. There's no reason to, because it doesn't have the astronomical oomph to spark anything right now. All right. So if that helps, good. If not, please ask another question. Ask it in a different way. I think I was trying to answer what I thought you were asking. So anyway, what else we got going on, Amanda?
Not much. Questions. It's just
Daniel Whitaker, rumors are rumors, okay, and that's it. It's not half the size of Jupiter, okay? The nucleus of the comet is literally fragmented now, and it's probably only, each segment is probably just like a couple of kilometers across at most, maybe less. In fact, it might only be a few hundred meters across at most. So we're not talking that the comet itself is huge. They're talking about the coma, that is that glow that we showed before. When we look at this glow here, okay, that you see that bluish glow. Now that's still 93 million miles away, roughly. So that bluish glow is about the size, half the size of the sun in diameter, actually, at 93 million miles away. So that's a pretty big size for just this gaseous cloud. And the gaseous cloud doesn't have any momentum to try and, they could hurt us, trust me. But the little particles that we cannot see here are the tiny sub, 2 kilometer size fragments of this comet, and those won't hurt anything. And I think that the thoughts that people say it's going to hit the Earth. Well, you know what? That's just because somebody probably saw somebody else being out of their mind on YouTube or something. And the YouTube generation, you can't believe everything you see. And I get
company excluded.
What do you mean? Oh yeah,
well,
being
streamed on YouTube.
No. I mean, but I'm talking about the conspiracy garbage, and that's what it is. It's garbage,
But Barrett does raise an interesting point, because I think it was Halebop, with that, oh my god, what was it called? Heaven's Gate? With Applegate guy?
Yeah.
So, and with the crazy things
Applewhite
going on in the world right now, did you ever think you'd be living through something like this? Like, it's not like, no one ever saw it coming. Like, it's unheard of. Like, it happens like every 100 years.
Yeah.
But to be living through it, you take something like a comet and possibly breaking up and this and that. Like, it's great material to run with.
It is. And, let's be honest, okay? And we did this on SkyTour Radio on our show, on KGRA Radio. We talked about the fact that sometimes, and there were theories out there that the pandemic we're suffering now was extraterrestrial in nature, that was delivered by a meteor or something that struck the Earth. A meteor wouldn't be a comet, because we would have noticed that. But the fact of it is that that's just a theory. And it's just as good a theory, because we don't know exactly the true origin of the COVID virus. And the reason that they said it came from extraterrestrial nature, or could have come from that source, is because a couple of weeks or so before the cases started in China, a large meteor struck in China, and like the Chelyabinsk type meteor. It was a meteor that came through, and it left a train and so forth in the sky, and people said, oh, that was delivering toxins, not meaningfully, but just delivering toxins. But the fact is, the heat from reentry is so hot that nothing virulent like a virus could survive that. But hey, that's the way it goes, man. But you know what? I do want to, I am deeply grateful that you guys are here tonight. Thank you for coming out. I do
questions. They came in pretty steady all night.
I love the questions. You guys are fantastic. That's
patience in me getting a chance to ask them all.
Yeah, we have a thinking crowd here. This is our sky right now. I know it looks like there's a lot of stars up overhead, but you know what? There's clouds here too. But because we're looking up overhead, we're looking through the cloud layer. When we look on the edge a little bit, as we go down toward a horizon, we're seeing through more air, and we see that the thickness of the clouds is really pretty steady down there. It's probably about this thick overhead, but we're not seeing it. This is really close to the horizon. This is a fisheye lens, so it's hard to really make this point properly, but it always looks clearer overhead than it really is, but in any case, I think we're gonna sign off because it was I think a very successful night. We actually got to check a few things out before the stream started. I'll just show you the last photo, or the photo that started the stream for me. I took, no, not that one. Not that one. Maybe that one. I went out to Venus and took a photo of our moon from Venus. No. This is actually Venus tonight. And the phase of Venus is going to get narrower, more crescent as time goes on, because Venus is actually coming toward us in our orbit. And how can you see that? Well, this is how you can see that. Okay, this little diagram that I had up here before to show you. This will show you, because if we look where the Earth is, okay, here's Earth, and here's Venus. Venus is going this way around the sun. Earth is going this way around. Earth's moving slower than Venus. Right now, Venus, as seen from the Earth, is going to have a partially illuminated shape. If we look at it kind of like at this low angle, you can see that the sun will be illuminating just under half of Venus as seen from us. And isn't that exactly what we see in this photo? Yes, it is. Exactly half of what we see with Venus. All right, and I took that tonight, and Venus set before I started the stream, so I wanted to have that available to show you guys. And then as Venus comes closer to us, like that, then less and less is going to be illuminated until finally Venus is going to be a very, very thin crescent, and we'll get shots of that too. Won't that be cool? But we're going to have to do that earlier and earlier, because Venus is getting closer to the sun too as that happens. So we'll do our best, Anyway, I want to thank you guys for coming out here to this wonderful stream. It was enjoyable to have you guys with us. So we'll start the stream and stop the stream with this photo of Venus that we took earlier tonight. My thanks for you, Amanda, for coming out. And of course, Daryl, my hats off to you as always. A real trooper. Thanks so much for coming out. And we will be coming back on the next clear night, and we'll look at the remains of our comet, and we will be back again as soon as possible. Yeah, and don't forget, SkyTour LiveStream West is still underway, delayed only by the virus, but I'm scheduled to be out there at the end of June to build the building. I've got a team of people that are going to be building this building. Marianne Robb, of course, is helping to coordinate everything. She is an angel. And I want to make sure that everyone knows that my book editor is here. Tara is here, Tara D.
Yes, I saw her.
Yep. And she went through every page of my book and found all the stupid mistakes I made and allowed me to correct them. So she's another one of those amazing people that you meet. So I wanted to make sure that she knew that I said that, because I am writing another book.
Are you?
Yeah, but I won't be talking about what I'm doing yet with it. But yes.
On your own?
Yeah, I'm not doing this one with Ket. Ket and I have Ket Thorvaldsen. We have a book we're going to be writing together as well. But this one is a different book that's just something that I'm writing. So, anyway.
Very nice. We look forward to it.
Yeah. So, folks, you guys have a good night, and I will be back on the next clear night. And remember, when you go out, keep looking up, okay?
And stay safe, everyone.
And stay safe. All right, folks. Good night.